Picture a quiet, darkened room that stretches for trillions of miles, where the raw, unformed material of the universe is suddenly ignited by the staggering energy of stellar infancy. The cold, empty vacuum is painted with the soft luminescence of a diffuse neon light, casting an ethereal, unbroken glow across the deepest reaches of the cosmic void. It is a monumental and silent awakening happening right this very second, a breathtaking beacon of creation blooming far beyond the fragile boundaries of our own solar system. Imagine a freezing, eternal darkness so thick and profoundly substantial that it creates a tangible, physical wall against the blinding, brilliant light of the entire surrounding galaxy. These colossal clouds of cosmic dust mass together in such staggeringly high concentrations that they effortlessly swallow the photons of a billion blazing suns without a single reflection. They loom ominously in the distance like the heavy, oppressive silence of a dense, lightless forest at absolute midnight, carefully hiding the universe's most ambitious and delicate construction projects from our view. Surprisingly, the grandest and most intensely solid-looking monuments in the heavens are constructed from almost entirely nothing at all, defying our terrestrial understanding of mass and physical structure. If we were to look closer and actually stand deep within the heart of one of these breathtaking cosmic clouds, the glowing gas is so incredibly diffuse that we would likely not even realize we were surrounded by a celestial masterpiece. The majestic, towering shapes we so eagerly admire from afar are merely shimmering, temporary ghosts woven from a substance so perfectly fragile that human hands could never hope to grasp it. This staggering cosmic journey is impossibly vast, but right here, resting in the quiet, familiar comfort of your own bed, your breathing naturally slows to match the unhurried pace of the turning galaxy. You're safe. These wonders are yours to inherit as you sleep. As the terrestrial world softly fades away and your eyes grow blissfully heavy, your consciousness is carried outward into the silent, sprawling canvas of the heavens. You're floating effortlessly and without fear toward the very dawn of star formation, leaving behind all the lingering weight of the day for the profound, absolute peace of the cosmic void. Our tranquil voyage into the mysteries of the night sky begins right now, drawing us directly toward the fiery, vibrant center of the celestial hunter. Deep within the Orion Nebula, vast clouds of hydrogen gas are illuminated by the fierce ultraviolet light of newborn stars. This celestial canvas glows with the soft luminescence of a diffuse neon light in a quiet, darkened room, casting an ethereal glow across the cosmic void. It is a silent awakening, where the raw, unformed material of the universe is suddenly ignited by the staggering energy of stellar infancy. The young stars, hidden deep within their gaseous cradles, burn with an intensity that violently strips electrons from the surrounding hydrogen atoms. As these electrons eventually recombine, they release cascades of photons that bathe the surrounding light years in a continuous, hauntingly steady radiance. This unbroken hum of visible light transforms an otherwise invisible expanse of cold, dark matter into a breathtaking beacon of creation. Observers witnessing this phenomenon are essentially looking at the very dawn of a solar system's life cycle. The gentle, neon-like glow serves as a universal monument to the relentless forces of gravity and nuclear fusion working in perfect, silent harmony. This cosmic structure is largely empty space, containing only a few thousand atoms per cubic centimetre, which is far emptier than any vacuum created in the most advanced laboratories on Earth. While these clouds appear thick, solid, and violently vibrant through the lenses of our telescopes, their true physical nature is an illusion born of sheer, incomprehensible scale. If a traveller were to sail a vessel directly through the heart of this glowing mist, they would find themselves surrounded by what appears to be a flawless, unending void. The soft, neon-like luminescence we admire from afar is the cumulative, aggregate glow of scattered atoms separated by vast oceans of absolute nothingness. It is only because we view these structures across expanses measuring trillions of miles that this whisper-thin scattering of matter overlaps enough to form a visible shape. The density is so vanishingly low that a single breath of terrestrial air contains more molecules than a volume of the nebula the size of an entire mountain. Thus, the grandest visual spectacles in the night sky are constructed from almost entirely nothing at all. They are shimmering ghosts woven from a substance so perfectly fragile that human hands could never hope to grasp it. Surprisingly, the universe paints these massive cosmic clouds with distinct, vibrant colours, based strictly on the specific chemical elements present within their sprawling tendrils. When the fierce ultraviolet radiation from massive central stars strikes the thin gas, it acts much like the electrical current flowing through a glass tube of neon gas. The resulting light is a precise glowing signature, with immense sweeps of pure hydrogen casting a deep, resonant crimson across the darkness. Interwoven within these scarlet fields are ethereal veils of blue and green, signalling the quiet presence of doubly ionized oxygen responding to the relentless stellar bombardment. These colours do not blend like terrestrial paints, but instead remain distinctly layered, creating a hypnotic glowing topography that maps the exact chemical anatomy of the cloud. Every hue observed is a direct, silent translation of atomic structure vibrating under immense energetic duress. It is a profound realization that the same elemental building blocks that compose water and organic life on our homeworld are broadcasting their identities across thousands of light years. The quiet room of space is thus perpetually lit by this massive, naturally occurring neon sign, revealing the fundamental chemistry of creation. If we were to look closer at the volatile heart of the Lagoon Nebula, we would see massive, swirling tornadoes of gas spanning over half a light year across. These colossal funnel clouds twist and writhe through the interstellar medium, driven by the intense temperature gradients and violent shearing winds unleashed by giant, blindingly hot O-type stars. The sheer scale of these atmospheric anomalies defies human comprehension, as a single vortex could easily swallow our entire solar system many times over. Despite their apocalyptic size and violent energetic origins, these twisting towers appear frozen in time when viewed from our distant vantage point. They emit a gentle, steady light, resembling the calm, soft hum of a solitary neon tube humming in a shadowy corridor, masking the turbulent chaos raging within. The delicate interplay of extreme heat and localized gravitational collapse forces the surrounding matter into these highly structured, mesmerizing fluid dynamics. Within the twisting walls of these cosmic tornadoes, the raw material for future planetary systems is being aggressively compressed and sorted. They are the brutal spinning engines of stellar engineering, relentlessly churning the vacuum to bring forth new light. Delicate filaments of microscopic dust scatter incoming starlight in reflection nebulae, creating a serene, enveloping blue haze that behaves exactly like Earth's own sunlit daytime sky. Unlike the aggressively ionized gases of emission nebulae, these quiet dust clouds do not generate any visible light of their own. Instead, they act as massive cosmic mirrors, catching the brilliant illumination of nearby companion stars and softly dispersing it through the surrounding dark void. This scattering phenomenon heavily favours the shorter, more energetic blue wavelengths of light, effectively painting the interstellar dust in cold, ghostly, azure tones. The resulting visual effect is one of profound stillness, mimicking the soft, diffuse glow of a solitary blue neon sign casting shadows in an otherwise pitch-black room. It is a cold, reflective beauty, utterly dependent on the grace of neighbouring luminaries to coax it out of total obscurity. The fine particles responsible for this majestic scattering are largely composed of simple carbon compounds and microscopic grains of silicate. Together, they form a vast, drifting fog that gently dims the brilliant stars behind it, draping the galaxy in a delicate, glowing blue veil. Picture a glowing cloud so unimaginably vast that a single photon of light, travelling at the absolute speed limit of the universe, takes dozens of years just to cross from one side to the other. To cross this same expanse in our fastest spacecraft would require millions of years of uninterrupted solitary flight through a silent, glowing fog. The sheer geographical footprint of these structures transforms them into self-contained universes of gas, dust, and radiant energy. As that photon journeys through the expanse, it navigates through varied densities of material, occasionally being absorbed and re-emitted by drifting atoms of hydrogen and helium. The resulting ambient light is a continuous collective sigh of radiation, bathing the interior in a soft, unbroken luminescence akin to a tranquil neon glow. There are no sudden flashes or rapid changes, only the agonizingly slow, beautiful procession of light conquering an immense silent darkness. This sprawling canvas is so monumental that an observer on one side would be completely unaware of a star detonating on the opposite side until a lifetime had passed. It is a monument to the staggering scale of cosmic architecture. Hidden deep within the sweeping folds of these ethereal structures are massive reservoirs of polycyclic aromatic hydrocarbons, complex organic molecules that glow intensely when viewed in infrared light. These carbon-based rings are surprisingly robust, surviving the harsh, radiation-drenched environment of open space, where more fragile molecular bonds are instantly shredded. They drift through the quiet vacuum in microscopic swarms, silently accumulating the raw chemical inventory required for potential future biospheres. While completely invisible to the naked human eye, these organic chains absorb ambient ultraviolet radiation and subsequently release it as a slow, warm infrared glow. This invisible luminescence permeates the darker, cooler regions of the cloud, operating much like a hidden neon network, humming steadily just beneath the threshold of visible perception. It reveals a hidden, parallel universe of complex chemistry, unfolding silently in the freezing shadows of the great gas pillars. The widespread presence of these complex molecules strongly suggests that the fundamental chemical precursors to life are not rare, but are instead a common structural component of the galaxy itself. The cold, dark voids between the stars are secretly teeming with the ingredients for living worlds. The intricate towering shapes we so eagerly observe, from monumental pillars to sweeping, delicate arches, are entirely carved by the relentless stellar winds blowing from massive central stars. These newly born behemoths are not gentle neighbours. They blast their immediate surroundings with hurricane-force torrents of superheated plasma and blinding ultraviolet radiation. This aggressive outflow acts as a cosmic sculptor's chisel, aggressively eroding the softer, less dense regions of the surrounding molecular cloud. What remains behind are the dense, stubborn knots of gas and dust that resist the gale, casting immense, light-years-long shadows that form the iconic, towering spires we see in astrophotography. The edges of these surviving structures glow with a fierce, compressed heat, outlining the dark dust like the sharp, curved glass tubing of an intricately designed neon lamp. It is a landscape defined entirely by erosion, where the most beautiful features are simply the last remaining survivors of a devastating stellar storm. As the winds continue to strip away the protective outer layers, the dense tips of these pillars are finally exposed to the brutal light. Within these eroding fortresses, the very last generation of infant stars desperately struggles to condense before their gaseous cradle is completely blown away. Notice how the magnificent Rosette Nebula so perfectly resembles a delicate, blooming celestial flower, a symmetrical shape deliberately sculpted by the intense radiation of a central cluster of young, incredibly hot stars. At the absolute heart of this crimson blossom lies a hollow, evacuated cavity where the fierce energy of the star cluster has completely pushed away the surrounding material. The edge of this expanding bubble forms the dense, glowing petals, which ripple and fold over themselves in a display of staggering fluid grace. The soft, deep red luminescence of the hydrogen gas is utterly hypnotic, radiating a calm, steady light that brings to mind the soothing atmospheric hum of a vintage neon sign hanging in absolute darkness. Despite the violent, explosive forces required to hollow out the core of the cloud, the resulting structure conveys a profound sense of mathematical peace and structural balance. Every filament and dark dust lane radiates outward from the centre, tracing the invisible paths of the stellar winds. This floral arrangement of gas and dust spans more than 100 light-years across, serving as a temporary beautiful monument to the stars that forged it. Eventually, the very stars that carved this blossom will blow the remaining petals apart entirely. These sprawling, glowing clouds are surprisingly ephemeral on a grand cosmic scale, firmly destined to completely dissipate or collapse within the span of just a few million years. While they appear as eternal, unmoving fixtures in humanity's brief historical record, they are actually fleeting, transitional phases in the chaotic life cycle of the Milky Way. The very processes that make them shine so brilliantly are exactly the same forces actively tearing them apart from the inside out. As the newborn stars within the cloud continue to grow and eventually detonate, their combined radiation and shock waves will eventually shred the delicate filaments, scattering the glowing gas back into the dark void. The soft, neon-like luminescence will slowly fade into memory as the gas dilutes, leaving behind only a loose, drifting cluster of naked sibling stars wandering the galaxy. The quiet room of space will once again plunge into absolute darkness, waiting for gravity to begin the arduous work of building a new cloud. To gaze upon a nebula is to catch a rare, fleeting glimpse of a masterpiece perfectly balanced on the razor's edge of its own destruction. Their temporary existence makes their soft, luminous beauty all the more profound against the cold eternity of the universe. Deep within the Orion Nebula, vast clouds of hydrogen gas are illuminated by the fierce ultraviolet light of newborn stars. This celestial canvas glows with the soft luminescence of a diffuse neon light in a quiet, darkened room, casting an ethereal glow across the cosmic void. It is a silent awakening, where the raw, unformed material of the universe is suddenly ignited by the staggering energy of stellar infancy. The young stars, hidden deep within their gaseous cradles, burn with an intensity that violently strips electrons from the surrounding hydrogen atoms. As these electrons eventually recombine, they release cascades of photons that bathe the surrounding light years in a continuous, hauntingly steady radiance. This unbroken hum of visible light transforms an otherwise invisible expanse of cold, dark matter into a breathtaking beacon of creation. Observers witnessing this phenomenon are essentially looking at the very dawn of a solar system's life cycle. The gentle, neon-like glow serves as a universal monument to the relentless forces of gravity and nuclear fusion, working in perfect, silent harmony. This cosmic structure is largely empty space, containing only a few thousand atoms per cubic centimetre, which is far emptier than any vacuum created in the most advanced laboratories on Earth. While these clouds appear thick, solid, and violently vibrant through the lenses of our telescopes, their true physical nature is an illusion born of sheer, incomprehensible scale. If a traveller were to sail a vessel directly through the heart of this glowing mist, they would find themselves surrounded by what appears to be a flawless, unending void. The soft, neon-like luminescence we admire from afar is the cumulative, aggregate glow of scattered atoms separated by vast oceans of absolute nothingness. It is only because we view these structures across expanses measuring trillions of miles that this whisper-thin scattering of matter overlaps enough to form a visible shape. The density is so vanishingly low that a single breath of terrestrial air contains more molecules than a volume of the nebula the size of an entire mountain. Thus, the grandest visual spectacles in the night sky are constructed from almost entirely nothing at all. They are shimmering ghosts woven from a substance so perfectly fragile that human hands could never hope to grasp it. Surprisingly, the universe paints these massive cosmic clouds with distinct, vibrant colours based strictly on the specific chemical elements present within their sprawling tendrils. when the fierce ultraviolet radiation from massive central stars strikes the thin gas. It acts much like the electrical current flowing through a glass tube of neon gas. The resulting light is a precise glowing signature, with immense sweeps of pure hydrogen casting a deep, resonant crimson across the darkness. Interwoven within these scarlet fields are ethereal veils of blue and green, signalling the quiet presence of doubly ionized oxygen, responding to the relentless stellar bombardment. These colours do not blend like terrestrial paints, but instead remain distinctly layered, creating a hypnotic, glowing topography that maps the exact chemical anatomy of the cloud. Every hue observed is a direct, silent translation of atomic structure, vibrating under immense energetic duress. It is a profound realization that the same elemental building blocks that compose water and organic life on our homeworld are broadcasting their identities across thousands of light years. The quiet room of space is thus perpetually lit by this massive, naturally occurring neon sign, revealing the fundamental chemistry of creation. If we were to look closer at the volatile heart of the Lagoon Nebula, we would see massive, swirling tornadoes of gas spanning over half a light year across. These colossal funnel clouds twist and writhe through the interstellar medium, driven by the intense temperature gradients and violent shearing winds unleashed by giant, blindingly hot O-type stars. The sheer scale of these atmospheric anomalies defies human comprehension, as a single vortex could easily swallow our entire solar system many times over. Despite their apocalyptic size and violent energetic origins, these twisting towers appear frozen in time when viewed from our distant vantage point. They emit a gentle, steady light, resembling the calm, soft hum of a solitary neon tube humming in a shadowy corridor, masking the turbulent chaos raging within. The delicate interplay of extreme heat and localized gravitational collapse forces the surrounding matter into these highly structured, mesmerizing fluid dynamics. Within the twisting walls of these cosmic tornadoes, the raw material for future planetary systems is being aggressively compressed and sorted. They are the brutal, spinning engines of stellar engineering, relentlessly churning the vacuum to bring forth new light. Delicate filaments of microscopic dust scatter incoming starlight in reflection nebulae, creating a serene, enveloping blue haze that behaves exactly like Earth's own sunlit daytime sky. Unlike the aggressively ionized gases of emission nebulae, these quiet dust clouds do not generate any visible light of their own. Instead, they act as massive cosmic mirrors, catching the brilliant illumination of nearby companion stars and softly dispersing it through the surrounding dark void. This scattering phenomenon heavily favours the shorter, more energetic blue wavelengths of light, effectively painting the interstellar dust in cold, ghostly azure tones. The resulting visual effect is one of profound stillness, mimicking the soft, diffuse glow of a solitary blue neon sign casting shadows in an otherwise pitch-black room. It is a cold, reflective beauty, utterly dependent on the grace of neighbouring luminaries to coax it out of total obscurity. The fine particles responsible for this majestic scattering are largely composed of simple carbon compounds and microscopic grains of silicate. Together, they form a vast, drifting fog that gently dims the brilliant stars behind it, draping the galaxy in a delicate, glowing blue veil. Picture a glowing cloud so unimaginably vast that a single photon of light, travelling at the absolute speed limit of the universe, takes dozens of years just to cross from one side to the other. To cross this same expanse in our fastest spacecraft would require millions of years of uninterrupted solitary flight through a silent, glowing fog. The sheer geographical footprint of these structures transforms them into self-contained universes of gas, dust, and radiant energy. As that photon journeys through the expanse, it navigates through varied densities of material, occasionally being absorbed and re-emitted by drifting atoms of hydrogen and helium. The resulting ambient light is a continuous collective sigh of radiation, bathing the interior in a soft, unbroken luminescence akin to a tranquil neon glow. There are no sudden flashes or rapid changes, only the agonizingly slow, beautiful procession of light conquering an immense silent darkness. This sprawling canvas is so monumental that an observer on one side would be completely unaware of a star detonating on the opposite side until a lifetime had passed. It is a monument to the staggering scale of cosmic architecture. Hidden deep within the sweeping folds of these ethereal structures are massive reservoirs of polycyclic aromatic hydrocarbons, complex organic molecules that glow intensely when viewed in infrared light. These carbon-based rings are surprisingly robust, surviving the harsh, radiation-drenched environment of open space where more fragile molecular bonds are instantly shredded. They drift through the quiet vacuum in microscopic swarms, silently accumulating the raw chemical inventory required for potential future biospheres. While completely invisible to the naked human eye, these organic chains absorb ambient ultraviolet radiation and subsequently release it as a slow, warm infrared glow. This invisible luminescence permeates the darker, cooler regions of the cloud, operating much like a hidden neon network humming steadily just beneath the threshold of visible perception. It reveals a hidden, parallel universe of complex chemistry unfolding silently in the freezing shadows of the great gas pillars. The widespread presence of these complex molecules strongly suggests that the fundamental chemical precursors to life are not rare, but are instead a common structural component of the galaxy itself. The cold, dark voids between the stars are secretly teeming with the ingredients for living worlds. The intricate, towering shapes we so eagerly observe, from monumental pillars to sweeping, delicate arches, are entirely carved by the relentless stellar winds blowing from massive central stars. These newly born behemoths are not gentle neighbours. They blast their immediate surroundings with hurricane-force torrents of superheated plasma and blinding ultraviolet radiation. This aggressive outflow acts as a cosmic sculptor's chisel, aggressively eroding the softer, less dense regions of the surrounding molecular cloud. What remains behind are the dense, stubborn knots of gas and dust that resist the gale, casting immense, light-years-long shadows that form the iconic, towering spires we see in astrophotography. The edges of these surviving structures glow with a fierce, compressed heat, outlining the dark dust like the sharp, curved glass tubing of an intricately designed neon lamp. It is a landscape defined entirely by erosion, where the most beautiful features are simply the last remaining survivors of a devastating stellar storm. As the winds continue to strip away the protective outer layers, the dense tips of these pillars are finally exposed to the brutal light. Within these eroding fortresses, the very last generation of infant stars desperately struggles to condense before their gaseous cradle is completely blown away. Notice how the magnificent Rosette Nebula so perfectly resembles a delicate, blooming celestial flower, a symmetrical shape deliberately sculpted by the intense radiation of a central cluster of young, incredibly hot stars. At the absolute heart of this crimson blossom lies a hollow, evacuated cavity, where the fierce energy of the star cluster has completely pushed away the surrounding material. The edge of this expanding bubble forms the dense, glowing petals, which ripple and fold over themselves in a display of staggering fluid grace. The soft, deep red luminescence of the hydrogen gas is utterly hypnotic, radiating a calm, steady light that brings to mind the soothing atmospheric hum of a vintage neon sign hanging in absolute darkness. Despite the violent, explosive forces required to hollow out the core of the cloud, the resulting structure conveys a profound sense of mathematical peace and structural balance. Every filament and dark dust lane radiates outward from the centre, tracing the invisible paths of the stellar winds. This floral arrangement of gas and dust spans more than 100 light-years across, serving as a temporary, beautiful monument to the stars that forged it. Eventually, the very stars that carved this blossom will blow the remaining petals apart entirely. These sprawling, glowing clouds are surprisingly ephemeral on a grand cosmic scale, firmly destined to completely dissipate or collapse within the span of just a few million years. While they appear as eternal, unmoving fixtures in humanity's brief historical record, they are actually fleeting, transitional phases in the chaotic life cycle of the Milky Way. The very processes that make them shine so brilliantly are exactly the same forces actively tearing them apart from the inside out. As the newborn stars within the cloud continue to grow and eventually detonate, their combined radiation and shockwaves will eventually shred the delicate filaments, scattering the glowing gas back into the dark void. The soft neon-like luminescence will slowly fade into memory as the gas dilutes, leaving behind only a loose, drifting cluster of naked sibling stars wandering the galaxy. The quiet room of space will once again plunge into absolute darkness, waiting for gravity to begin the arduous work of building a new cloud. To gaze upon a nebula is to catch a rare, fleeting glimpse of a masterpiece perfectly balanced on the razor's edge of its own destruction. Their temporary existence makes their soft, luminous beauty all the more profound against the cold eternity of the universe. Against the cold eternity of the universe, some of the most striking cosmic monuments are born not from fiery beginnings, but from quiet endings. These delicate structures, historically misnamed as planetary nebulae, have absolutely nothing to do with actual planets orbiting a star. The confusing moniker was coined centuries ago by early astronomers who, peering through primitive telescopes, saw only faint glowing orbs that superficially resembled gas giants like Uranus or Neptune. Instead of rocky worlds or swirling atmospheres, these glowing spheres represent the expanding ripples of a much grander final act. As you picture this historical misunderstanding, let your breathing slow, mirroring the gentle outward expansion of gas into the dark vacuum. The true nature of these objects was obscured for generations by the sheer, staggering distances that rendered their intricate internal details invisible to human eyes. This misclassification stands as a testament to our enduring desire to categorize the unknown by comparing it to the familiar objects of our own solar neighborhood. Only with the advent of advanced spectroscopy did humanity finally realize they were looking at the ghostly remains of dead stars. They are not planets, but the radiant tombs of suns that have gracefully surrendered to the dark. This cosmic structure represents the gentle, final exhalation of a dying star remarkably similar to our own sun, softly casting its outer layers adrift into deep space. Unlike the cataclysmic, violent detonations of more massive stars, this process unfolds with the quiet grace of expanding ripples on a calm pond after a stone is gently dropped. The star simply reaches the end of its nuclear fuel, its core contracting while its outer envelope swells and slowly drifts away. To witness this expansion is to look into a mirror reflecting the distant, inevitable destiny of our own solar system billions of years from now. As the stellar atmosphere drifts outward, it carries with it the memory of a lifetime spent fighting against the crushing, inward pull of gravity. The resulting shroud of gas floats elegantly, a fleeting masterpiece painted by a fading artist. Deep within the iconic Ring Nebula lies a white dwarf, the incredibly dense, searingly hot core left behind after the star's nuclear fusion engines permanently shut down. Stripped of its vast insulating outer layers, this exposed heart is roughly the size of the Earth, but packs half the mass of an entire star. It is a brilliant, ultra-compressed diamond of carbon and oxygen, burning with a fierce residual heat that defies the surrounding cold. As you visualize this dense, glowing ember, notice the steady rhythm of your own pulse, a comforting anchor in the face of such profound cosmic extremes. The gravitational pull on the surface of this tiny remnant is so incomprehensibly strong that a single teaspoon of its material would weigh tons on our planet. It stands as a silent sentinel in the center of the void, anchoring the very gas it just expelled. The expanding ring of gas we see from afar is continuously illuminated by the fierce, invisible light pouring from this tiny, fading point of extreme density. Though it produces no new energy, the core will take tens of billions of years to completely cool and fade into a dark, frozen cinder. Until then, it remains the glowing epicenter of the ripples it set into motion. If we were to look closer at the Cat's Eye Nebula, we would discover a mesmerizing series of complex concentric rings echoing outward through the dark. These perfectly spaced halos are not random formations. They're a physical, visual record of the star's violently pulsating final thousands of years. Much like the rings of a cosmic tree, each glowing shell represents a massive rhythmic ejection of mass thrown off during regular 1,000-year intervals. The exact mechanism behind these incredibly regular pulsations remains one of the most captivating mysteries of stellar death, hinting at hidden magnetic cycles or unseen stellar companions. As the star gasped for survival, it convulsed, puffing out perfectly spherical shock waves that travelled outward exactly like ripples propagating across a perfectly still lake. Over millennia, these individual ripples stacked upon one another, creating a breathtaking multi-dimensional labyrinth of glowing gas. Today, the combined structure presents an optical illusion of intersecting ovals and glowing arcs that challenge our fundamental understanding of fluid dynamics in a vacuum. The sheer precision of these concentric shells reveals the surprisingly mathematical nature of a star's final, desperate struggle against its own collapse. They are the beautiful, fossilized heartbeats of a sun that has long since stopped beating. Surprisingly, the universe sculpts these dying breaths into a staggering, almost infinite variety of geometric shapes, ranging from perfect, undisturbed spheres to incredibly intricate, twisting hourglasses. One might expect a spherical star to always produce a perfectly round cloud of debris as it dies in the frictionless vacuum of space. Yet the reality is a chaotic, artistic gallery of celestial forms where no two planetary nebulae look exactly alike. The serene, rippling expansion is frequently interrupted and reshaped by hidden forces, such as powerful magnetic fields that twist the outflowing plasma into complex spiraling lobes. Fast-moving stellar winds can suddenly overtake slower, earlier ejections, crashing into them and ploughing the gas into sharp, glowing boundaries and dramatic, sweeping curves. It is an environment where the delicate physics of expanding gas collides with the fierce, invisible architecture of electromagnetism. Take a deep breath and let your shoulders drop, appreciating the wild, unpredictable beauty that emerges from these invisible cosmic conflicts. From distant vantage points, these distorted clouds resemble soaring butterflies, staring eyes, or delicate crystalline snowflakes frozen in the deep void. The universe refuses to adhere to simple symmetry, preferring instead to craft wildly unique monuments out of every single dying star. Picture the sprawling expanse of the Helix Nebula, where a closer inspection reveals thousands of intricate cometary knots, which are incredibly dense droplets of gas actively resisting the stellar wind. These bizarre, tadpole-shaped structures feature bulbous, glowing heads facing the central white dwarf, with long, trailing tails swept back by the unrelenting radiation. They are the cosmic equivalent of heavy boulders standing firm in the middle of a rushing, shallow river. Each of these knots is roughly the size of our entire solar system, yet they appear as mere tiny specks of dust within the colossal architecture of the greater nebula. The material within these droplets is exceptionally cold and dense, allowing them to momentarily survive the intense, blistering heat of the passing shockwaves. As the fast stellar wind crashes against them, it sculpts their tails, drawing the material out into long, elegant, glowing streaks. Eventually, even these stubborn islands of gas will be eroded entirely, boiled away into the vacuum by the relentless, invisible fire of the dying star. For now, they hang suspended in the void, a testament to the clumpy, uneven nature of the stellar atmosphere before it was finally cast off. They are the last, dense remnants of a sun's outer skin, fighting a beautiful, losing battle against their own dispersion. These delicate glowing shells do not remain stagnant. They expand outward into the void at astonishing speeds of tens of kilometers per second, carrying a precious cosmic cargo. Over the course of its long life, the central star acted as a massive nuclear furnace, slowly fusing simple hydrogen and helium into heavier, more complex elements like vital carbon and oxygen. The nebula is the delivery mechanism, silently releasing these newly forged materials into the impoverished surrounding interstellar medium. It is an act of profound cosmic generosity, spreading the fundamental building blocks of future planets and potential biology across the quiet, rippling expanse of the galaxy. Without this gentle, outward distribution of heavy elements, the universe would remain a sterile, primitive wasteland composed only of the lightest, simplest gases. As you rest in this moment, recognize that the very carbon forming your cells was once expelled in a silent, expanding ripple exactly like this. The expanding gas eventually slows as it collides with the thin, ambient material of deep space, seamlessly blending its enriched contents into the greater cosmic ocean. This process ensures that the death of one star directly fertilizes the desolate void, perfectly setting the stage for the next grand cycle of creation. The ethereal beauty of the cloud is simply the visual byproduct of the galaxy chemically enriching itself. Notice how the dramatic, deeply pinched bipolar shape of the Ant Nebula heavily suggests the secret gravitational influence of a hidden companion star shaping the outflowing gas. Instead of expanding freely in all directions, the dying star's exhalation is violently restricted around its equator, forcing the material to blast outward from the poles in two massive opposing lobes. This fierce constriction creates an hourglass figure that perfectly mimics the segmented body of a celestial insect. The unseen partner, likely a smaller, dimmer star orbiting in close proximity, acts as a gravitational propeller, sweeping up the ejected gas and slinging it outward at extraordinary speeds. The complex orbital dance between the dying giant and its companion weaves a dense, invisible disk of material that acts as a physical nozzle, directing the subsequent stellar winds. It is a stunning visual manifestation of a binary relationship where the silent partner dictates the final shape of the monument. The resulting high-speed jets of plasma crash into the surrounding slower-moving older gas, creating brilliant glowing shock fronts at the absolute extremes of the lobes. This intricate, violently shaped structure stands in stark contrast to the peaceful, rippling spheres of isolated stars, proving that cosmic companionship often ends in spectacular, chaotic displays. The hidden star ensures that its dying partner does not fade away gently, but instead leaves a dramatic, lasting scar across the darkness. A typical planetary nebula is a surprisingly fleeting phenomenon on the grand scales of cosmic time, remaining visible for only a few brief tens of thousands of years. While this span seems like an eternity to the human mind, it is a mere fraction of a blink in the multi-billion-year lifespan of the star that created it. The expanding ripples of gas simply travel too fast, racing away from the central core until they become too thin to hold a shape. As the gas disperses and expands further into the freezing vacuum, the density drops, plummeting towards zero, gradually extinguishing the beautiful neon-like glow of the structure. Simultaneously, the exposed central white dwarf is constantly losing heat, its ability to illuminate the retreating cloud diminishing with every passing century. Feel the ground supporting your weight as you contemplate this transient beauty, a brief, luminous spark fading seamlessly back into the dark cosmic background. Eventually, the intricate shells, the cometary knots, and the hourglass lobes will all thin out completely, becoming entirely indistinguishable from the rest of the cold interstellar void. The visual masterpiece is erased, leaving behind only the microscopic, enriched dust grains drifting silently through the galaxy. To witness one of these objects is to catch an incredibly rare, perfectly timed snapshot of a star in the very brief moment of its true passing. The extreme, blistering ultraviolet radiation pouring from the central white dwarf is so incredibly intense that it violently strips electrons from the surrounding expanding gas cloud. This high-energy bombardment is the sole reason the nebula is visible at all, transforming a cold, expanding graveyard of dead stellar material into a brilliantly glowing fluorescent beacon. As the torn electrons eventually recombine with their parent atoms, they release distinct photons of visible light, causing the entire structure to sing in vibrant colours. This process of ionization and recombination happens trillions of times a second across the entire span of the nebula, generating a steady, unbroken luminescence that pierces the dark. The light we observe is not the heat of a fire, but the cool, electric glow of a vast, naturally occurring plasma lamp operating in the frictionless vacuum. The central core, though tiny, wields enough energetic influence to light up a volume of space thousands of times larger than our solar system. As the gas continues its outward journey, resembling the fading, expanding ripples on our cosmic pond, it eventually travels beyond the reach of the dwarf's ionizing rays. When that invisible threshold is crossed, the fluorescence abruptly stops, and the gas plunges back into the freezing, eternal dark from which it was briefly summoned. The glow is a temporary, brilliant borrowed light, a final, magnificent echo of a sun that has already died. As the star's iron core collapses in a fraction of a second, the outer layers are rebounded outward at a significant percentage of the speed of light, creating a wall of fire that consumes everything in its path. This creates a vast, hollowed-out sphere of star stuff that hurtles into the surrounding void, forever changing the landscape of the interstellar medium. The result is a structure of chaotic beauty, a sprawling graveyard that serves as both a monument to a star's life and a violent herald of its end. Observers across the universe see these remnants as expanding shells of glowing gas, but they are actually high-speed collisions occurring on a scale that defies human comprehension. Every wisp of light is a signature of a once mighty furnace that has been completely unmade. It is a transition from a singular, focused point of light into a diffuse, complex tapestry of energy. Deep within the heart of the Crab Nebula, the wreckage of such a stellar demise hides a ghost that remains startlingly active even after its parent body has been reduced to dust. A rapidly spinning neutron star, the ultra-dense and compressed core of the original giant, acts as a cosmic dynamo that continues to power the glowing filaments of the entire debris cloud. This pulsar rotates dozens of times per second, whipping its intense magnetic field through the surrounding space with enough force to accelerate particles to nearly the speed of light. This mechanical precision creates a wind of high-energy particles that pushes outward, re-inflating the surrounding nebula and keeping it brilliantly lit long after the initial explosion has passed. It is a strange, persistent heartbeat within a body that has already been destroyed, a mechanical rhythm vibrating through the silence of the void. This core is so dense that a single fragment the size of a city would contain the mass of the entire human race. Feel the steady weight of your own body against your chair, a calm and grounded contrast to the frantic, dizzying rotation of this stellar remnant. While the pulsar spins with a fury that could tear planets apart, it provides the steady energy that makes the nebula's beauty visible to our eyes. It is the engine at the centre of the ruin, refusing to let the light fade. This violent expansion does not occur in a vacuum of total emptiness, but instead sweeps up the surrounding interstellar material like a giant invisible snowplow. As the star's remains collide with the thin gas between stars, they create a colossal shockwave that heats the material to temperatures of millions of degrees. At such extreme thermal levels, the gas becomes invisible to human eyes, but screams in the high-energy spectrum of intense X-rays. These invisible fronts of energy are the true boundaries of the explosion's reach, carving out a territory of fire in the freezing reaches of space. The shockwave acts as a furnace, stripping atoms of their electrons and forcing the gas to broadcast its presence across the galaxy in frequencies we can only see with specialized machines. It is a harsh, searing environment where the normal rules of temperature are forgotten in the wake of the star's final kinetic burst. Within this boundary, the very atoms of the interstellar medium are compressed and transformed, forced into a new state of existence by the passing of the star. The shockwave is the frontier of the star's influence, pushing outward until it finally loses its momentum against the dark. It represents the point where the star's individual history becomes part of the galaxy's larger story. Surprisingly, the universe relies on these explosive remnants to perform a vital service that no peaceful star can ever achieve during its steady, billion-year life. While smaller suns forge light elements like helium and carbon, it is only during the catastrophic final seconds of a supernova that the most precious and heavy elements, such as iron, gold, and uranium, are created in significant quantities. These remnants act as cosmic sours, scattering these newly forged atoms throughout the galaxy so they can eventually be incorporated into the foundations of new worlds. The gold in a wedding ring or the iron in your blood was once part of a violent, expanding cloud of debris similar to the one you're now visualizing. Without these destructive echoes, the universe would remain chemically stagnant, lacking the complexity required to build rocky planets or complex life. This destruction is, in a very literal sense, the ultimate act of creation, providing the raw materials for everything we have ever known or loved. As you rest in this moment, allow your hands to relax, realizing that the very elements within your bones were once born in this exact kind of celestial fire. We are made of the debris of these ancient explosions, carrying the history of a dying star in every cell of our bodies. The remnant is not just a distant object, but our own ancestral cradle. If we were to look closer at the Veil Nebula, the ferocity of the original explosion is revealed as something delicate and almost fragile in its appearance. We see the lace-like structures of a shockwave that has been expanding for thousands of years, appearing as fine, glowing threads woven through the darkness. These filaments are actually thin sheets of gas seen edge-on, where the shockwave has compressed the interstellar medium into brilliant luminous walls that ripple like silk. As the wave slows down and interacts with the uneven density of space, it wrinkles and folds, creating the appearance of a translucent cosmic veil that stretches across light years. It is a visual paradox, a remnant of one of the most violent events in nature, now presented as a soft, intricate tapestry of light. The colours within these threads, pinks, blues, and greens, represent the different elements being excited as the wave passes through them. Take a moment to allow your jaw to loosen, finding a sense of peace in the realization that even the greatest chaos eventually settles into a form of quiet, structured elegance. The veil is a ghost of a disaster, yet it provides one of the most serene views in the northern sky. It shows us that even the most shattered things can find a way to be beautiful again. Picture an expanding bubble of hot gas that stretches for hundreds of light years in every direction. A hollow sphere that acts as a monument to a singular stellar event. As it travels, it carves out massive cavities in the interstellar medium, essentially hollowing out the galaxy and leaving behind vast, low-density voids that can persist for millions of years. These superbubbles define the large-scale architecture of the Milky Way, acting as pockets of hot plasma that push back against the colder, denser clouds where new stars are born. The interior of such a bubble is so thin and hot that it acts as a highway for high-energy cosmic rays, allowing them to travel vast distances without being blocked by dust or gas. From the outside, these bubbles look like ghost-like spheres of influence, marking the territory of a star that vanished millennia ago. They are the empty footprints of giants, evidence that a single life, however distant, can permanently reshape the geometry of a galaxy. This structure eventually cools and slows, its walls becoming the nurseries for the next generation of stars as the compressed gas begins to collapse under its own weight. The bubble is both an ending and a beginning, a boundary between the past and the future. It is the breath of the galaxy, moving in slow rhythmic cycles of expansion and contraction. The Cassiopeia, a remnant, contains bright clumps of pure oxygen and sulfur that were forged in the heart of the star right before it exploded. These chemical clumps were not mixed or diluted by the explosion. They were ejected with such force that they now fly through space as distinct, unpolluted clouds of elemental matter. It is as if the star's internal organs were suddenly exposed to the universe, frozen in their final state of nuclear synthesis for us to observe. By studying these specific clumps, astronomers can map out the exact layers of the original star, essentially performing a cosmic autopsy on a sun that died 3 centuries ago. The intense colours of these ejector knots, vivid greens and deep oranges, reveal the precise moment when the star's nuclear furnace finally failed and the core collapsed. It is a rare direct encounter with the raw products of stellar alchemy, captured before they can blend into the background of the void. This remnant is one of the youngest in our galaxy, and its light only reached Earth in the late 17th century, though it likely went unnoticed by many. It serves as a time capsule, preserving the chemistry of a massive star in its final heartbeat. The sulfur and oxygen we see there are the same elements that sustain life on our planet today. Remarkably, the universe usually moves at a pace that makes it appear static to us, but the fast-moving knots of ejecta in these nebulae can be tracked over mere human lifetimes. If an observer were to take a photograph today and compare it to one taken just a decade ago, they would see these bright shards of gas visibly changing position and shape against the background stars. These knots are travelling at speeds exceeding 5 million miles per hour, a velocity so high that the transition of the cloud is observable in real time. This visible motion brings a startling sense of immediacy to the study of the cosmos, reminding us that we live in a dynamic, ever-changing environment. As you feel the gentle rise and fall of your chest with every breath, recognize that somewhere in the distance, pieces of a shattered star are racing across the void with incredible purpose. The stillness of the night sky is often a lie of perspective. In reality, these remnants are living, breathing monuments of constant motion. Watching these knots move is like watching the explosion in slow motion, even hundreds of years after it actually occurred. It connects our brief human experience to the vast, sweeping timelines of the stars. We are witnesses to a process that is still unfolding, a story that is not yet finished. The magnetic fields within a supernova remnant can trap high-energy electrons in a relentless, spiraling dance, producing a faint, continuous glow known as synchrotron radiation. This light is fundamentally different from the glowing gas seen in other nebulae, as it is generated by the movement of particles themselves rather than the heating of atoms. It creates a smooth, ethereal luminescence that fills the gaps between the bright filaments, giving the remnant a ghostly three-dimensional volume. This radiation is a hallmark of high-energy physics, a sign that the magnetic legacy of the dead star is still exerting control over the particles around it. The glow is a soft, non-thermal hum of light that permeates the entire structure, acting like a background radiation that defines the nebula's shape in radio and X-ray frequencies. It is the final, magnetic signature of the star, a lingering presence that refuses to be extinguished even after its light has faded. Within this magnetic web, the history of the star's rotation and its final collapse is preserved in the orientation of the light. It is a silent record of a powerful force that once governed a solar system. Even in its shattered state, the star maintains a grip on the space it once occupied. Some remnants feature a mysterious and beautiful string of glowing pearls, which is actually a ring of material ejected long before the explosion and later illuminated by the flash. Decades or centuries before the final supernova, the star may have cast off a belt of gas that sat quietly in the dark, invisible to any observer. When the star finally exploded, the sudden burst of light and energy hit this pre-existing ring like a flashbulb, making it light up in a perfect glowing circle of brilliant knots. This celestial jewellery provides a glimpse into the star's pre-death behaviour, showing that the end was not a single event but a long, drawn-out process of shedding mass. The pearls are not the explosion itself but the echoes of the star's final years, brought back to life by the very energy that destroyed their creator. It is a final, poetic illumination of the past, a sequence of lights that trace the history of a sun that has long since vanished. As the years pass, these pearls will eventually fade as the light from the explosion moves further into the void. They are a temporary bridge between the star's former life and its final dissolution into the interstellar medium. The ring remains as a final, elegant circle, closing the story of a massive star before it becomes part of the freezing eternal dark. The freezing eternal dark is not merely an empty absence of matter, but is often a presence so thick and substantial that it creates a tangible wall against the brilliant light of the galaxy. Dark nebulae are these colossal clouds of cosmic dust, massing together in such high concentrations that they completely obstruct the visible light from the dense star fields and glowing gases situated behind them. They loom in the distance like the heavy silence of a dense, lightless forest at absolute midnight, where the very air feels weighted with an unseen, ancient substance. In these regions, the vacuum of space is replaced by a drifting, opaque fog of carbon and silicates that swallows photons whole, rendering vast sections of our sky seemingly hollow. Yet, this darkness is an illusion of perspective, a barrier that protects the delicate chemical processes occurring within its frigid heart from the harsh radiation of the outside universe. It is a place of profound stillness, where time seems to stretch, and the frantic energy of the stars is muffled by a velvet shroud. To look upon such a cloud is to witness the universe in its most private, unadorned state, holding its breath before the next great act of creation begins. This void is not a lack of life, but the quietest concentration of its ingredients. It is the silence between the notes of a cosmic symphony, providing the necessary pause that gives the surrounding light its true meaning. Deep within the colossal nebula, the individual grains of dust are far more complex and delicate than simple soot or inert rock. Each microscopic particle is coated with a thin, microscopic layer of frozen water, carbon monoxide and ammonia, creating a celestial frost that clings to the matter in the deep, unwavering chill of space. This icy plating acts as a vital laboratory, providing a surface where atoms can meet and bond in the silence, forming complex molecules that could never survive in the warmer, more energetic regions of the cosmos. The chemistry of these dark clouds is a slow, patient alchemy, occurring at temperatures only a few degrees above absolute zero. As the frost accumulates, these grains become heavy and sticky, clumping together into larger structures that will one day form the foundations of new worlds. The colossal is not just a shadow, it is a frozen archive of the galaxy's potential, preserving the volatile ingredients of life within a protective layer of ice. These microscopic ice mantles act as shields, preventing the fragile bonds of newly formed molecules from being shattered by the stray rays of distant dying suns. It is a quiet, cold preservation that ensures the seeds of future solar systems remain intact until the moment they are needed. Within this frost, the history of the universe is written in frozen chemical shorthand, waiting for the warmth of a new sun to thaw the secrets hidden inside. This structure often presents a frighteningly beautiful illusion to the human eye, appearing as an empty void or a jagged ink-black hole torn directly into the starry tapestry of the night sky. In reality, these regions are brimming with cold, dense molecular material, packed more tightly and substantially than almost anywhere else in the interstellar medium. What looks like an absolute absence of anything at all is actually the most significant concentration of matter in the local void, waiting in the heavy silence for gravity to complete its work. As you contemplate this hidden depth, feel your breath becoming slow and rhythmic, matching the ancient, unhurried pace of these cold and massive clouds. The perceived whole is simply a curtain, a dense collection of molecules so effective at scattering light that they create the most perfect shadows in nature. Within this density, the temperature remains incredibly low, preventing the gas from expanding and allowing the cloud to maintain its integrity against the surrounding vacuum. It is a reservoir of potential energy, a silent weight that presses against the fabric of space-time with the quiet authority of an incoming tide. The universe uses these dark patches to hide its most ambitious construction projects, ensuring that the work of building a star remains undisturbed by the light of the neighbours. Behind the mask of the void, the machinery of creation is in full motion, working toward a destiny we cannot yet see. Surprisingly, the universe utilises these dark and forbidding frigid clouds as the necessary quiet incubators for the absolute earliest stages of star and planet formation. Within the pitch-black heart of these shadows, the lack of light and heat allows gravity to begin its delicate and patient work without the constant interference of disruptive high-energy radiation. It is a nursery of shadows, where the most brilliant futures are whispered into existence long before the first spark of nuclear fusion is ever ignited. The extreme cold is not a hindrance, but a requirement, as it allows the gas to lose its internal pressure and surrender to the pull of its own mass. In the total darkness, tiny pockets of the cloud begin to spin and flatten, forming the seeds of suns and the disks of future planets, in a process that takes millions of years of undisturbed peace. These dark nebulae serve as the womb of the galaxy, protecting the fragile embryos of solar systems from the violent winds and searing heat of the open interstellar plains. Without this protective darkness, the gas would be too agitated to ever coalesce, and the galaxy would remain a beautiful but sterile expanse of drifting atoms. The shadows are the silent partners in every light that has ever shone in the night sky. Every sun began its life as a cold, shivering knot of gas hidden in a place just like this, safely tucked away in the midnight of the stars. If we were to look closer at the Horsehead Nebula, we would realise that its famous and distinct dark silhouette is not a permanent monument, but is instead being slowly and relentlessly eroded by the intense light of a nearby bright star. The fierce ultraviolet radiation acts as a cosmic wind, stripping away the outer layers of the dust cloud and causing the dark, horse-like shapes to retreat over the course of millions of years. This iconic figure is a transient shadow, a silhouette caught in the very process of being slowly reclaimed by the surrounding glowing light of the emission nebula it rests against. As the radiation heats the edges of the dust, the material boils off into space, creating a glowing bright rim that outlines the dark shape with a fierce, ephemeral brilliance. The Horsehead is essentially a dense promontory of gas that has resisted the stellar winds longer than the material around it, but its eventual dissolution is inevitable. It is a masterpiece of erosion, standing firm like a cliffside against a relentless and invisible ocean of light. The beauty we see today is a snapshot of a slow-motion disappearance, a reminder that even the most solid-looking shadows in the sky are in a state of constant, graceful flux. One day, the horse will vanish entirely, leaving behind only the brilliant stars that caused its departure. It is a sculpture carved by the light that will eventually consume it, a final profile before the dawn. These dusty clouds are masters of disguise, only revealing their intricate internal structure and hidden infant stars when astronomers observe them through the penetrating eyes of infrared or radio wavelengths. By shifting our perspective beyond the narrow limits of the visible, the opaque walls of dust become suddenly transparent, unveiling a secret world of glowing protostars and swirling gas. It is like turning on a warm lantern in a cold, dark room, suddenly making sense of the shapes and movements that were previously hidden in the impenetrable gloom. Notice the stillness in your limbs as you consider this hidden clarity, echoing the profound and heavy quiet of these regions where visible light itself is turned away. In the infrared, the heat from forming stars glows like embers through the soot, showing us the exact locations where gravity is currently winning its battle. This multi-wavelength vision allows us to peer through the skin of the nebula to see the skeleton of the galaxy's construction projects. These observations prove that the darkness is never truly empty, but is instead a vibrant and active workspace, where the future is being meticulously assembled. The dust that blocks our view is also the very medium that records the heat of creation, serving as a thermal diary of the stars yet to be born. Through the eyes of machines, we can finally witness the secrets kept by the midnight forest, seeing the fire within the smoke. Notice how the intricate and twisting shapes of the Snake Nebula seem to slither through the dense star fields, tracing the otherwise invisible magnetic fields that thread through the galactic plane. These dark, serpentine ribbons are not random formations. They follow the unseen lines of magnetic force that govern the movement of matter on a truly massive scale. The dust acts as a high-contrast dye in a celestial stream, revealing the complex and invisible currents that steer the evolution and rotation of our entire galaxy. These magnetic fields act as a stabilizing force, preventing the cloud from collapsing too quickly while also guiding the flow of material into dense, star-forming filaments. The resulting shape is a cosmic map of a force that we cannot see, feel, or hear, but which dictates the very architecture of the heavens. As the cloud twists, it anchors itself to the larger magnetic structure of the Milky Way, connecting the local darkness to the grand rotation of the galactic disk. The dust grains within these dark clouds are surprisingly microscopic, often similar in size to the tiny particles found in common smoke from a campfire or the fine ash of a volcanic eruption. Despite their minuscule individual nature, they collectively span across light years of space, forming a barrier so vast and effective that it can hide thousands of suns and an entire galaxy's worth of light. It is the power of the incredibly small multiplied by the near infinite, a reminder that even the finest mist can eventually obscure the brightest light if given enough volume. Each grain is a tiny shard of silicate or carbon, forged in the atmospheres of dying stars and cast out into the void to wander for eons. They are the soot of the stars, the refuse of ancient stellar furnaces that has found a new purpose as the building blocks of shadow. These particles are so fine that they would pass through the weave of most fabrics, yet they are the very things that make the sky dark in the most crowded parts of our galaxy. As they drift in the silence, they collide and stick together, slowly growing from smoke to sand to pebbles. This microscopic debris is the fundamental ancestor of every mountain and every grain of sand on our own world. The deep silence of the forest is built one tiny microscopic grain at a time, woven into a darkness that eventually births the light. Barnard 68 stands as a perfect and haunting example of this cosmic magic, appearing as a completely opaque black ink blot against the background stars when viewed in visible light. However, when viewed through specialized infrared telescopes, the cloud becomes miraculously and completely transparent, allowing the light from thousands of distant stars to pass through like sunlight through a clean window. This striking duality highlights the thin line between the seen and the unseen, reminding us that darkness is often just a matter of the specific light we choose to use. Let your thoughts drift like these light-filtering clouds, moving effortlessly between the shadow and the clarity as your body remains heavy and relaxed. The nebula is so well defined and isolated that it provides a perfect laboratory for studying the exact moment a cloud decides to become a star. It is a globule of potential, a singular unit of darkness that holds exactly enough mass to collapse if given just the slightest nudge from a passing shockwave. Gravity is constantly engaged in a silent, epic battle against internal thermal pressure and invisible magnetic fields within the deep, pressurized hearts of these dark clouds. This localized struggle is a slow-motion war of attrition that eventually leads to a dramatic and inevitable stellar collapse as the cloud finally gives way to its own crushing weight. From this final and complete surrender to the dark comes the sudden and brilliant birth of a new star, proving that the deepest shadows are merely the prelude to the most radiant beginnings. As the center of the cloud begins to fall inward, the temperature begins to rise, transforming the cold molecular gas into a hot spinning disk of energy. The heavy silence of the dark nebula is finally broken by the first light of a newborn sun, which begins to push back against the darkness that once protected it. This transition is the ultimate paradox of the nebula journey. The very material that hid the light eventually becomes the light itself. The struggle between gravity and pressure is the heartbeat of the cosmos, a rhythmic dance of death and rebirth that ensures the fire of the universe never truly goes out. In the end, every shadow is just a star that hasn't found its spark yet. The dark forest eventually gives way to the dawn of a new solar system, blossoming out of the silence. Blossoming out of the silence of the dark forest, the universe transforms into a vast and intricate laboratory where nebulae serve as the grand chemical factories of the galaxy. Within these sprawling ethereal clouds, simple and solitary atoms of hydrogen, carbon and nitrogen begin a slow and deliberate dance, bonding together to form increasingly complex molecular chains. This chemical evolution is a silent, invisible revolution, turning the raw, primitive elements of the Big Bang into the diverse building blocks of a structured and vibrant universe. As you imagine these tiny bonds forming across light years of space, you might detect a sharp, metallic tang of ozone in your mind, much like the air lingering just after a fierce lightning storm has passed. This sensory sharpness mirrors the high-energy interactions that occasionally spark new chemical pathways in the freezing dark gas. These factories operate with a patient persistence, processing the recycled material of ancient dead stars into the potential for new and varied systems. The transition from simple, drifting gas to complex life-sustaining molecules represents the fundamental alchemy of the entire cosmos. Every wisp of glowing gas is a visible testament to the universe's innate ability to organize itself into higher and more sophisticated states of complexity. From these grand factories, the galaxy breathes out the molecular blueprints that will eventually define the physical nature of entire worlds and the life they may one day harbor. Deep within the gargantuan Sagittarius B2 cloud located near the chaotic center of our galaxy, astronomers have discovered staggering quantities of ethyl formate, a complex organic molecule with a very specific signature. This is the exact chemical compound responsible for the distinct sharp aroma of rum and the sweet tart flavor of ripe raspberries on Earth. It is a whimsical and profound realization that the very heart of our galaxy is essentially perfumed with the scent of a summer harvest, drifting through the vacuum in vast, intoxicating clouds. The discovery of such a specific, flavor-defining molecule proves that the chemical diversity of the interstellar medium is far richer and more familiar than we ever dared to imagine. These molecules are not merely rare anomalies found in tiny pockets, but are instead produced in quantities that could fill entire oceans, floating as a gaseous vapor between the distant burning stars. The metallic tang of ozone in the high-energy nebula environment provides the sharp electric backdrop for these sweet organic signatures to develop and persist. This aromatic cloud serves as a cosmic reminder that the universe is not a sterile, alien or unreachable place, but one filled with the familiar ingredients of our own sensory experiences. The complex chemistry required to define the taste of a fruit in a terrestrial garden was first written in the stars of the galactic core. Even in the deepest reaches of space, the universe seems to be practicing the recipes for the living worlds that are yet to come. This structure acts as a vital, dark safe haven where massive concentrations of dust grains shield delicate molecules from being immediately destroyed by the harsh, unrelenting ultraviolet starlight. In the open interstellar medium, the intense radiation from massive suns would instantly shatter the bonds of complex molecules, reducing them back to their simplest, most primitive atomic states. However, within the protective and opaque folds of a nebula, the dust grains absorb and scatter this destructive energy, creating a sanctuary where chemistry can flourish in absolute peace. This cosmic shielding is the primary reason that the building blocks of prebiotic life can persist long enough to be incorporated into newly forming planetary systems. The thick, opaque veils of the nebula act as a planetary defense system, ensuring that the patient work of the chemical factories is not undone by the very stars they were born to create. The environment inside remains cool and relatively tranquil, despite the energetic violence and radiation occurring just outside the cloud's boundary. As these molecules huddle in the shadows, they are free to grow into longer and more intricate chains without the threat of being unmade. The dust is the guardian of the galaxy's potential, holding the line against the searing, bleaching light of the void. In this silence, protected from the solar wind, the universe weaves the complex and durable fabric of materiality. Surprisingly, the universe synthesizes the fundamental building blocks of life, such as amino acid precursors, floating freely in the icy depths of these majestic dark clouds. These molecules, which serve as the essential components of all known proteins, are not exclusive to biological organisms, but are forged by the natural inorganic processes of the nebular environment. They exist as a drifting molecular mist, waiting for the moment they can be delivered to the surface of a young, cooling planet by a passing comet or meteor. As you contemplate these cosmic precursors, feel the gentle support of the surface beneath you, allowing your resting body to sink into a state of deep, restorative relaxation. While you remain still and grounded, the universe is actively assembling the very chemistry of existence in the freezing, absolute dark of the interstellar medium. The sharp, metallic tang of ozone signals the energetic shifts that allow these complex life-bearing structures to take root in the vacuum. This discovery bridges the gap between the vast, incomprehensible scales of astronomy and the intimate molecular details of our own biology. It strongly suggests that the seeds of life are not a local accident, but a universal constant, distributed widely throughout the galaxy's star-forming regions. We are not just looking at cold gas and dust. We are looking at the raw, unrefined material of our own ancient and cosmic ancestry. If we were to look closer at the expanding translucent shells of planetary nebulae, we would find Buckminster fullerenes, massive and beautiful spherical molecules composed of exactly 60 carbon atoms. These molecules, often affectionately called buckyballs, resemble microscopic soccer balls or geodesic domes, representing one of the most stable and complex forms of pure carbon in the universe. They were first detected in space within the cooling wreckage of dying stars, proving that the vacuum can host structures of incredible geometric precision and strength. The formation of C60 in the harsh and cooling environment of a dying sun is a testament to the resilience and versatility of carbon-based structures. These spheres are incredibly tough, capable of surviving the intense radiation and high-speed collisions that define the long and arduous nebular journey through the galaxy. The sharp, metallic tang of the surrounding gas underscores the industrial-scale alchemy required to fuse these 60 atoms into a single, perfect, and hollow sphere. These buckyballs may act as cosmic containers, trapping other atoms or smaller molecules inside their carbon cages as they drift through the interstellar void. They are the high-tech hardware of the interstellar medium, representing a level of structural sophistication that mirrors our own most advanced human chemistry. In the debris of a dead star, the universe builds the most durable and symmetrical architectural wonders of the molecular world. Picture a slow-motion chemical reaction taking thousands of years to complete, facilitated entirely upon the cold, hard surface of a single microscopic dust grain. In the vacuum of space, atoms are so sparsely distributed that the chance of them randomly colliding and bonding in the void is vanishingly small. The dust grains act as cosmic meeting places, providing a physical surface where drifting atoms can land, stick, and finally find one another to form a lasting bond. This surface chemistry is the secret engine behind the galaxy's incredible molecular diversity, acting as a catalyst that speeds up reactions that would otherwise never occur. The grains hold the atoms in place, allowing them to vibrate and shift until they snap together into a stable and functional molecule. This process is so slow and patient that it defies our human understanding of time, unfolding over centuries for a single molecular chain to grow. As you rest, imagine the quiet metallic scent of ozone as the energetic catalyst for these tiny ancient connections occurring in the dark. The dust is the silent matchmaker of the cosmos, bringing order to the chaos one individual atom at a time. Without these microscopic surfaces, the universe would remain a lonely and sterile expanse of individual particles, never finding the strength to join together into something greater. The Boomerang Nebula holds the distinct and chilling title of being the coldest known natural place in the entire discovered universe, with temperatures plunging to just 1 degree above absolute zero. This extreme environment is created as the nebula expands so rapidly that its internal temperature drops far below the ambient 3-degree glow left over from the Big Bang. It is a refrigerator of cosmic proportions, outcooling even the deepest, emptiest voids of intergalactic space through the pure and relentless physics of adiabatic expansion. Allow the muscles in your face and jaw to completely relax, finding a sense of profound and heavy stillness as you envision this ultimate silent chill. The air around you feels familiar, safe, and warm compared to this absolute biting cold where all molecular motion almost entirely ceases. The metallic tang of ozone seems to sharpen in the mind, a frozen sensory edge in an environment that is colder than the very background of the universe itself. In this extreme state, the nebula acts as a unique and invaluable window into the physics of the ultracold. It is a place where the normal rules of thermal energy are pushed to their breaking point, creating a localized pocket of near-perfect stasis. This coldness is not a lack of activity, but a direct result of a star's final, violent expansion, proving that even destruction can lead to a quiet, frozen peace. Surprisingly, carbon monoxide exists as the second most abundant molecule in these vast clouds, and serves as a vital tracer for astronomers mapping the galaxy's cold gas distribution. While hydrogen is the most common element, it is notoriously difficult to detect with radio telescopes when it is cold and non-luminous. Carbon monoxide, however, broadcasts a steady, reliable and sharp radio signal that acts as a beacon, revealing the hidden contours and densities of the otherwise invisible molecular clouds. By tuning our instruments to the specific frequency of this molecule, we can see the grand, sweeping architecture of the Milky Way's spiral arms, which are defined by these cold, dark reservoirs. The carbon monoxide molecule is effectively the cartographer's ink of the cosmos, tracing the boundaries of every major star-forming region in the night sky. Its presence signals the locations where the next generation of stars is currently being prepared, acting as a reliable indicator of the galaxy's future fertility. The metallic tang of ozone in the air is a sharp reminder of the chemical complexity that these carbon-bearing molecules represent to our understanding. This simple pairing of carbon and oxygen is the master key that unlocks our view of the galaxy's hidden and massive structures. Through this humble tracer, we find the maps to the universe's most private and productive nurseries. If we were to look closer, we would see that complex sugars like glycolaldehyde have been detected in the gas surrounding young binary stars, hinting at the ubiquitous nature of prebiotic chemistry. This molecule is a simple form of sugar, a direct relative of the carbohydrates that fuel all life on Earth, and its presence in a star-forming region is a discovery of staggering importance. It proves that the ingredients for a biological kitchen are being prepared and stocked long before the planets themselves have even finished forming. These sugars are detected in the swirling, glowing disks of material that will eventually coalesce into new rocky worlds, suggesting that the chemistry of life is baked into the foundation of a planet from its inception. The binary stars provide the perfect energetic environment where the sharp, metallic tang of ozone and radiation catalyzes the formation of these sweet and complex precursors. It is a discovery that moves the origin of life's ingredients back by billions of years into the nebula phase. Knowing that sugars drift between the stars changes our fundamental perspective on the hospitality and potential of the wide cosmos. The universe is not a hostile or empty desert, but a garden in waiting, filled with the nutritional potential for an entire future biosphere. From these simple, drifting grains of sugar, the staggering complexity of a living world becomes a tangible and inevitable possibility. Every single atom of oxygen you breathe, and every carbon atom in your very DNA once drifted slowly through the sprawling, glowing expanse of an ancient nebula. You're not merely a detached observer of these cosmic clouds, you are a literal, physical extension of their ancient and patient chemical labour. The atoms that compose your body were forged in the white-hot hearts of distant suns and then exhaled into the void, passing through the grand chemical factories of the past to eventually find their way here. Take a final deep breath and feel the weight of your own cosmic history, recognizing the profound and unbreakable connection between your life and the distant metallic tang of the nebula ozone. Your resting body is a collection of ancient stardust that has finally found a way to look back at the place where it was originally born. The journey from a simple hydrogen atom in a glowing cloud to the complex consciousness you possess now is the greatest and most beautiful story the universe has ever told. The nebulae are the grand and silent ancestors of all that is solid, living and breathing in our world, providing the bridge between the simple beginning and the complex present. We are the universe's way of experiencing and understanding its own alchemy, a conscious realization of the labour of the stars across eons. In every breath you take, you're recycling the legacy of a cloud that blossomed out of the silence eons ago. The legacy of a cloud does not end at the invisible boundaries of our own galaxy, but instead stretches into the vast intergalactic dark where the scale of creation expands beyond our comprehension, weaving a tapestry of light that spans the entire observable universe. Beyond our own Milky Way, giant extragalactic nebulae illuminate the sweeping spiral arms of neighbouring galaxies, like vibrant glowing jewels set against a velvet cloth of absolute shadow, serving as luminous beacons across the void that prove the fundamental processes of birth and illumination are universal constants throughout the infinite expanse. These distant structures are the sprawling, interconnected threads of a vast spiderweb catching the morning dew of cosmic time, representing massive concentrations of star-forming material that mirror our own local nurseries, but on a scale that defines the very architecture of a galaxy. And by observing these distant fires, we realise that our own local wonders are merely a single, sparkling thread in a much larger and more complex cosmic web. Deep within the large Magellanic Cloud, our closest galactic companion, lies the monstrously large and radiant Tarantula Nebula, a structure that challenges every human definition of scale and serves as a testament to the raw, unyielding power of the cosmos. This star-forming region is so incredibly luminous that if it were placed as close to us as the Orion Nebula, its light would be strong enough to cast visible, sharp shadows on the surface of the Earth, essentially turning the night sky into a theatre of brilliant monochromatic daytime. It pulsates with a frantic energy that signals the presence of the most massive and luminous stars ever discovered by our species, reaching across hundreds of light years with glowing gas filaments that resemble the legs of a gargantuan celestial arachnid frozen in the silence of the void. This massive structure spans over 1,000 light years and contains superstar clusters harbouring hundreds of thousands of massive, fiercely burning young stars in a state of perpetual nuclear fury, collectively radiating enough energy to reshape the very fabric of their host galaxy. These clusters are the true powerhouses of the extragalactic landscape, radiating energy with such intense ferocity that they can push gas completely out of the galactic disk and into the intergalactic medium, effectively hollowing out their parent galaxy from the inside out. As you envision these dense knots of brilliant light and the colossal bubbles of hot plasma they create, feel the quiet weight of your body settling into the surface beneath you, acting as a calm and steady anchor against the unimaginable pressure of this cosmic storm. Surprisingly, the universe connects even the most distant and isolated galaxies through a faint, almost invisible intergalactic medium composed of ancient gas and drifting dust that has remained largely undisturbed since the very first minutes of cosmic time. Occasionally, this thin and ghostly medium condenses into enormous glowing gas clouds that float entirely outside the traditional boundaries of any single galaxy, acting as wandering islands of light that catch the collective glow of the entire universe like threads of a spiderweb catching the first rays of a distant dawn. These intergalactic clouds represent the shared heritage of all matter and prove that no galaxy is truly an isolated island in the great, dark ocean of the void, but is instead part of a continuous fluid exchange of the raw materials required for future suns. If we were to look closer at the hearts of active galaxies, we would encounter colossal emission nebulae powered not by the gentle and steady light of newborn stars, but by the extreme searing radiation of a central supermassive black hole. As matter spirals into the gravitational abyss of the galactic center, it releases a torrent of energy that causes the surrounding gas clouds to glow with an intensity that can be seen across billions of light years, creating a haunting monochromatic beauty born from the very edge of oblivion. This is a landscape of extreme physics, where the most destructive force in nature unexpectedly becomes the primary source of illumination, carving out a territory of fire in the deep freeze of space and serving as a radiant indicator of the violent processes that govern galactic evolution. The intricate and beautiful spiral structure of a galaxy is largely defined visually by the sharp, dramatic contrast of its internal glowing elements, where the dark lanes of cold, obscuring dust act as a deep silhouette against the bright pink knots of active emission nebulae. These pink highlights follow the graceful curves of the spiral arms like glowing pearls on a thread, marking the specific regions where the galaxy is most alive and fertile, and where the next generation of solar systems is being meticulously assembled in the quiet of the dark. Without these nebulae to provide texture and definition, the majestic spirals we admire would appear as faint, ghostly smears of ancient starlight, rather than the vibrant, structured wheels of creation that drive the ongoing chemical enrichment of the entire universe. Notice how the massive Andromeda galaxy, our nearest cosmic sibling, contains its own unique versions of our local nebulae, mirroring the familiar landmarks of our own night sky in a distant mirror that spans over 2 million light-years of empty space. Though they are visible only to our most powerful telescopes due to the immense distance, these sister clouds serve as a profound and comforting connection between our world and theirs, proving that the same physical laws and chemical building blocks are at work everywhere we look. Allow your mind to drift like the morning dew on the threads of the cosmic web, finding a deep sense of peace in the repetitive and beautiful patterns of the stars, knowing that the glowing gas and dark dust of Andromeda are identical to the cradle that once held our own sun. Lyman alpha blobs are mysterious, giant glowing gas clouds found only in the extremely early universe, existing when the cosmos was just a small fraction of its current age and shining with a primitive light that has travelled for over 10 billion years to reach our eyes today. These structures are thought to be the massive, chaotic ancestors of modern galaxies, caught in the very moment of assembling themselves through the relentless inward pull of gravity, representing the first thick threads of the spiderweb being woven together in the dark conditions of the ancient past. Each blob is a colossal reservoir of gas that dwarfs our own Milky Way, a violent and beautiful struggle to bring order to the initial chaos of the Big Bang and lay the foundations for every star city that would eventually inhabit the expanding void. When galaxies collide in a slow-motion cosmic dance that takes hundreds of millions of years to complete, the sudden and violent compression of their gas clouds triggers a galaxy-wide starburst of unimaginable scale that illuminates the entire merging system. This event lights up thousands of new, brilliant nebulae simultaneously, transforming what could be a dark and destructive collision into a dazzling festival of fire and light, where the shock waves from the merger act as a giant bellows to stoke the fires of 1,000 new nurseries. It is the ultimate synthesis of destruction and birth, where the end of two separate galaxies marks the beginning of a single, larger, and more vibrant union, ensuring that the merge system will be filled with brilliant light and fresh chemical potential for billions of years to come. The promise of chemical potential for billions of years to come is a horizon we have only recently learned to map, a journey that began with the simplest of descriptions for the most complex of wonders. The word nebula itself is a quiet, ancient echo, translating simply from the Latin for cloud, a term used by early astronomers as a humble catch-all for any fuzzy, unidentifiable object in the night sky. In those early centuries, as they pressed their eyes against the cold brass of primitive instruments, anything that could not be resolved into individual stars was cast into this category of celestial mist. It was a beautiful admission of a limit, a way of acknowledging that some parts of the heavens remained stubbornly out of reach, appearing only as ghostly stains against the deep black. These early observers were limited by the smooth, heavy glass of their optics, which lacked the power to peel back the layers of these distant structures. To them, a star-forming nursery and a dying sun's gasp appeared much the same, both shrouded in the same ambiguous nomenclature of the fog. This linguistic simplicity reflects a time when the universe was smaller and more mysterious, a period where we were just beginning to name the shapes that haunted the peripheries of our vision. As you consider the origins of these names, feel the steady, rhythmic expansion of your lungs, echoing the slow pace of human discovery. Every wisp of light was a challenge to the intellect, a cosmic cloud waiting for a name that could match its true physical majesty. Deep within the historical records of the Northern Song dynasty, the sudden and brilliant arrival of a guest star in the year 1054 was meticulously documented with a precision that still guides modern science. This ancient light was the supernova that birthed the remains we now recognize, but for the astronomers of the time, it was a profound omen that appeared in the morning sky for nearly a month. They recorded its brightness and its position relative to known constellations, leaving a trail of ink that would eventually link their era to our own understanding of stellar death. This cross-generational observation serves as a bridge, proving that the events of the deep past are etched as much in human memory as they are in the light years of space. The records tell of a light so intense it was visible even during the bright glare of high noon, a feat of radiance that surely inspired awe and perhaps fear in those who watched it. To those ancient eyes, it was not an expanding shell of gas or a magnetic pulsar, but a temporary and brilliant addition to the celestial order. It is a humbling thought that the very data we use today to calculate the expansion of these ruins was first gathered by individuals who watched from stone observatories nearly a millennium ago. Their patience and attention to detail created a legacy that survives the dissolution of empires. We find ourselves today looking at the same coordinate in space, though through far more powerful lenses, witnessing the consequences of that singular recorded flash. The transition from a guest star to a well-studied remnant is a story of human continuity in the face of an ever-changing universe. This structure, the brilliant and iconic heart of the celestial hunter, holds a mystery that puzzles historians. It was never once mentioned in the detailed texts of ancient astronomers or even by Galileo during his initial revolutionary surveys. Despite its modern status as the most photographed and recognized nebula in the night sky, its official discovery only came in 1610, when it was documented by Nicolas Claude Fabry de Peiresc, using a telescope of his own design. It is a strange omission, as the cloud is often visible to the naked eye under truly dark skies, appearing as a faint blurry star in the centre of the hunter's sword. Some wonder if the gas was less active or less luminous in antiquity, or if the sheer familiarity of the constellation caused observers to overlook the subtle haze within it. As Peiresc turned his instrument toward that specific patch of dark, he was the first to realize that what appeared to be a singular point of light was actually a vast glowing field of fluid energy. This discovery marked a turning point in how we viewed the composition of the heavens, shifting the focus from individual stars to the sprawling environments that contain them. Take a moment to allow your jaw to soften and your shoulders to drop, feeling the weight of your own presence in this current documented moment of history. We are part of the first few generations to truly see this nursery for what it is, a privilege that escaped even the greatest minds of the Renaissance. The mystery of its late discovery serves as a reminder that the universe often hides its greatest wonders in plain sight, waiting for the right combination of technology and curiosity to bring them into the light. Peiresk's observation was the first step in a 400-year journey to map the cradle of stars. It remains a cornerstone of our astronomical heritage, a light that was always there, waiting to be truly seen. Surprisingly, the limitations of 19th century science forced astronomers to invent an entire fictitious element called nebulium to explain a pervasive and mysterious green glow found within many celestial clouds. This brilliant emerald light did not match the spectral signatures of any known element found on Earth, leading many to believe they had discovered a fundamental component of the universe that existed only in the reaches of space. For decades, this phantom element was part of the scientific consensus, a placeholder for a phenomenon that defied the chemical logic of the era. It was a period of creative struggle, where the beauty of the observation outpaced the ability to define its physical source. The truth was eventually revealed to be far more elegant. The green light was not from a new element, but from common oxygen in an extremely rare, doubly ionized state that can only exist in the incredibly low densities of a near-perfect vacuum. In the dense atmosphere of Earth, these atoms would collide and lose their energy before they could emit that specific green photon, making the light literally impossible to recreate in a terrestrial laboratory. This realization transformed our understanding of the interstellar medium from a collection of exotic materials into a realm where familiar elements behave in extraordinary ways under extreme conditions. The fictitious element vanished, replaced by a deep appreciation for the physical laws that govern the behavior of atoms across the void. This shift from the imaginary to the precisely understood marks the maturation of astrophysics as a discipline that links the small to the grand. The green glow we see today is no longer a mystery of chemistry, but a signature of the incredible emptiness that allows light to travel undisturbed for trillions of miles. It is a reminder that the universe is composed of the same building blocks we find at home, just waiting for the right environment to reveal their hidden colours. If we were to look closer at the famous catalogue created by Charles Messier, we would realise that it was originally born out of a sense of frustration, rather than a desire to study these glowing structures for their own sake. Messier was a dedicated comet hunter, and he found that static, fuzzy objects in the sky were a constant source of annoyance, leading him on false trails as he searched for moving visitors to our solar system. To save himself time and disappointment, he began to compile a list of these static nebulae, labeling them as things to be ignored so he could focus on his true passion. This to avoid list inadvertently became the foundation for one of the most important and beloved collections of deep sky objects in the history of astronomy. Each entry in his catalogue was a shortcut to efficiency, a way of saying that this specific patch of light would not move and was therefore of no interest to a man chasing the fleeting tails of icy travellers. Little did he know that the objects he was dismissing as distractions were actually the massive nurseries, dying stars and distant galaxies that define the large-scale structure of our universe. Today, amateur and professional astronomers alike still use his numbering system to navigate the heavens, finding beauty in the very objects he once viewed as a nuisance. It is a poetic irony that his name is now forever synonymous with the very things he was trying to avoid. The smooth, heavy glass of his telescopes was focused on the hunt, yet it captured the enduring architecture of the cosmos. As you consider this accidental legacy, let your hands and feet become heavy and relaxed, resting in the quiet comfort of your own surroundings. We often find our greatest contributions in the margins of our intended work, leaving behind a map that others will use to find the wonders we overlooked. The true nature of spiral nebulae as completely separate distant galaxies was the subject of a fierce and historic intellectual struggle known as the Great Debate, which divided the scientific community for years. Many prominent astronomers argued that these swirling shapes were simply localized clouds of gas within our own Milky Way, representing the earlier stages of new solar systems forming close to home. The debate was not just about the distance of these objects, but about the very size and scope of the entire known universe. It was a battle of perspective that challenged our sense of place in an increasingly vast and intimidating cosmos. This fundamental question was finally settled in the 1920s when Edwin Hubble utilized a specific type of pulsating star within the Andromeda spiral to measure its distance with unprecedented accuracy. His calculations revealed that the object was millions of light years away, far beyond the boundaries of our own galaxy, effectively proving that the universe was populated by countless other star cities. In a single moment of discovery, the known universe expanded by a factor of millions, shifting our world from the center of everything to a small, isolated outpost in an ocean of other galaxies. The spiral nebulae were no longer just clouds. They were vast and complex systems containing billions of stars of their own. As you absorb the scale of this expansion, feel the gentle support of the ground beneath you, providing a stable foundation in an unimaginably large universe. Hubble's work transformed the fuzzy patches of light in our telescopes into windows looking out at other worlds. It was the moment we finally realized that the tapestry of the night sky was far deeper and more intricate than we had ever dared to dream. Modern astrophotography frequently relies on a sophisticated technique involving narrow-band filters that map specific elements to distinct colours, most famously seen in the iconic Hubble palette images. In this system, the light from sulfur is mapped to red, the radiance of hydrogen to green, and the glow of oxygen to blue, creating a vibrant three-dimensional view that reveals the chemical distribution within the cloud. While these are not the true colours a human eye would see through a telescope, they're a powerful scientific tool that allows us to visualise the complex physical processes occurring across light years of space. This artistic translation of raw data into colour helps us understand which stars are heating the gas and how different elements are interacting in the cosmic wind. The resulting images are some of the most famous and inspiring views of the cosmos, presenting the nebulae as towering, multicoloured cathedrals of light and shadow. The choice to map hydrogen to green is particularly striking, as hydrogen is the most abundant element and provides the primary texture and structure to these massive clouds. This technique turns the invisible chemical anatomy of a nebula into a visual masterpiece that is as scientifically accurate as it is aesthetically profound. It is a bridge between the cold, analytical data of the telescope and the human need for beauty and colour. By looking through these specific filters, we can separate the different layers of the nebula, seeing exactly where the heavy elements forged in stars are being distributed back into the void. It is a form of scientific art that makes the abstract complexity of the universe accessible to our senses. Every colour represents a specific atom, reacting to the energy of a distant star, a chromatic code for the building blocks of matter. William Herschel was a pioneer who discovered thousands of these celestial clouds, meticulously cataloguing the night sky with telescopes that featured some of the largest and most powerful mirrors of his time. He was the first to correctly hypothesize over 2 centuries ago that, while some of these objects were distant clusters of stars that appeared fuzzy due to distance, others were truly composed of a shining ethereal fluid. This was a revolutionary idea that suggested space was not a perfect vacuum, but was instead filled with a material substance that could glow and move like a liquid. His observations were the first to distinguish between the collection of stars and the raw material that stars are made from. Working in the quiet, damp nights of the English countryside, Herschel used the cold brass of his instruments to peer deeper into the dark than anyone before him. He viewed the galaxy as a dynamic and changing system, a vast garden where stars were born, grew old, and eventually died, leaving behind their gaseous remains. His daughter and son joined him in this massive undertaking, creating a family legacy of observation that defined our early maps of the heavens. They were the first to move beyond simply naming the lights to asking what they were made of and how they had come to be. The realization that an ethereal fluid filled the gaps between the stars was the birth of modern interstellar physics. It shifted our focus from the points of light to the spaces between them, recognizing that the voids were just as active and important as the stars themselves. Herschel's vision of a living, breathing universe continues to inspire every astronomer who looks through the heavy glass of a telescope today. The intricate naming conventions of these structures reflect the diverse history of their discovery, spanning from sterile, cold catalogue numbers like NGC 7000 to highly whimsical and descriptive names like the North American Nebula. The formal numbers are the language of professional research, providing a precise and universal coordinate for scientists to share their findings across the globe. In contrast, the popular names are born from the human imagination, which naturally seeks to find familiar patterns, such as animals, shapes, or landscapes, within the chaotic and swirling clouds of gas and dust. This dual identity allows the same object to be both a data point in a vast database and a source of wonder and storytelling for the public. Notice the peaceful stillness in your limbs as you consider these two ways of seeing, one focused on the cold precision of the machine and the other on the warmth of human perception. Whether we call a structure by its NGC number or by its resemblance to a blooming flower, we're all looking at the same grand manifestation of cosmic energy. These names are our way of claiming the distant reaches of space, making the incomprehensible scale of the universe feel just a little more like home. The North American Nebula, for example, is a massive region of hydrogen gas that just happens to align into a shape we recognize, a coincidence of perspective that bridges the gap between the galactic and the terrestrial. These naming patterns show that we cannot help but bring our own history and geography with us when we look out at the stars. We see our own faces and the shapes of our continents reflected back at us in the glowing debris of the void. It is a final poetic layer of human observation, turning the cold brass and smooth glass of our telescopes into tools for a new kind of mythology. Our fundamental understanding of these cosmic clouds shifted most dramatically with the launch of specialized space telescopes, which finally allowed us to peer entirely through the obscuring walls of dust using infrared vision. For centuries, the dense, cold clouds of the dark nebulae had remained impenetrable mysteries, hiding the secrets of star birth behind a veil that visible light could not cross. By moving our observatories above the interference of the Earth's atmosphere and tuning them to the heat signatures of the universe, we have finally seen the hidden fires that burn within the shadows. This breakthrough has revealed that the darkest parts of our sky are actually the most active and vibrant, filled with thousands of newly forming suns that were once completely invisible to us. The transition from visible to infrared observation is like suddenly being able to see through the walls of a house to the life moving inside. We no longer have to guess what lies within the pillars of gas. We can see the exact points of light where gravity is winning its final battle. This new perspective has confirmed that the cycle of destruction and birth is a continuous, interconnected process that spans the entire galaxy. The space telescopes have turned the heavy, lightless forests of the dark nebulae into transparent windows of discovery, showing us the true engine of galactic evolution. This concludes our historical and scientific journey of observation, marking the point where our species finally developed the eyes to see the universe in its entirety. As the light from these distant, glowing clouds continues to travel toward us, we remain in a state of constant, quiet awe, forever refining our maps of the deep. The observers and the observed are finally united in a single, clear vision of the cosmic tapestry. Within this cosmic tapestry, some structures defy our expectations of chaos, appearing with a geometric precision that seems almost artificial to the human eye. The red rectangle nebula exhibits a striking X-shape and perfectly spaced horizontal rungs that remarkably resemble a glowing cosmic ladder ascending into the dark. These rungs are likely shockwaves or pulses of gas ejected from a central binary star system every few hundred years, caught in the shimmering rainbow-slick light of its own unique chemistry. As the light reflects off the dust grains, it produces an iridescent glow that shifts and dances like a thin film of oil on water. The symmetry of this nebula is a profound puzzle for astrophysicists, suggesting a highly ordered process in the heart of a dying star system. The ladder rungs are remarkably consistent in their spacing, indicating a rhythmic, periodic event that is repeated for millennia. This mathematical beauty is framed by the X-shape, which is formed by the intersection of two cone-shaped outflows of gas and dust. It stands as a testament to the structured and almost architectural nature of the universe's most bizarre creations. The colours here are predominantly red, driven by the presence of complex carbon molecules that absorb ultraviolet light and re-emit it in the visible spectrum. This process creates a haunting, steady luminescence that illuminates the rungs like a staircase leading into the unknown depths of the galaxy. It is a structure of singular, strange beauty, inviting us to reconsider the complexity of the interstellar medium and the hidden order that governs the transition of a star from life into shadow. Deep within the core of the Egg Nebula, a similar mystery of symmetry unfolds as concentric arcs of gas expand outward, like ripples on the surface of an iridescent liquid. These shells are meticulously spaced and are illuminated by brilliant searchlight beams escaping through holes in a dense, dark cocoon of dust that surrounds the central star. The effect is hypnotic and deeply serene, mimicking the shifting rainbow colours of an oil slick as the light scatters through the expanding layers of the star's former atmosphere. Each searchlight beam cuts through the gloom like a lighthouse across a foggy sea, revealing the hidden topography of the expanding gas. The star at the heart of this nebula is in the process of transitioning into a planetary nebula, shedding its outer layers in rhythmic bursts that create the concentric circles we observe. These arcs represent tens of thousands of years of stellar history, frozen in light and preserved in the freezing vacuum of space. The dust cocoon is so thick that it completely hides the star itself, allowing only these slivers of light to escape into the wider universe. This produces a dramatic play of shadow and brilliance that changes depending on our vantage point. The searchlight beams are a rare visual phenomenon, showing us the exact path of the star's radiation as it interacts with the surrounding matter. This interaction creates a shimmering, multicolored glow that seems to pulse with a life of its own, reminding us of the active forces still at work in the center of the cloud. It is a scene of quiet, cinematic wonder, where the hidden and the seen are perfectly balanced. The Egg Nebula serves as a bridge between the unseen center and the expansive beauty of the cosmic garden. If we were to look closer at the Eskimo Nebula, we would find a structure that challenges the cold sterility of space with a form that looks surprisingly organic and familiar. This planetary nebula possesses unusual filaments of gas pointing away from the center, deeply resembling the intricate furry hood of a winter parka wrapped around a bright central face. These filaments are actually giant, dense cometary knots of gas that are being eroded by the fierce stellar wind of the central white dwarf. As you envision these delicate strands, take a moment to notice the gentle weight of your limbs and the steady rhythm of your breath, feeling completely anchored and secure as you observe this distant, frozen portrait. The central face of the nebula is actually a bubble of gas being blown outward by the star's radiation, creating a nested series of shells that add to the illusion of a human profile. This structure is a masterpiece of fluid dynamics, where the interaction of different gas speeds creates a complex web of textures and shadows. The colours shift from a deep, vibrant blue in the outer hood to a warm, glowing green in the central regions, reflecting the varying ionisation of oxygen and nitrogen. It is a visual symphony that demonstrates how the universe can sculpt raw matter into shapes that resonate with the human spirit. The cometary knots forming the fur each several times the size of our entire solar system, yet from our distance, they appear as fine, soft hairs. This scaling of the immense into the familiar is one of the most charming paradoxes of the night sky, bringing the distant stars into a closer, more personal focus. It remains a favourite among observers for its whimsical appearance and its profound display of the physics of gas and light. In the silence of the void, this parka-clad phantom stands as a witness to the star's final, elegant transformation. Surprisingly, the universe created the Thor's helmet Nebula through a much more aggressive and high-energy process than the gentle shedding of a sun-like star. This majestic structure is driven by a massive and unstable Wolf-Rayet star at its centre, which is rapidly blowing a hot interstellar bubble into a surrounding molecular cloud. The interaction carves out a complex winged shape that looks remarkably like the legendary helmet of a Norse god, complete with sweeping side pieces and a central dome. The intense radiation causes the edges of the nebula to glow with the same shimmering, hypnotic variety of colours seen in a thin film of oil, tracing the violent boundary where stellar wind meets ancient gas. The Wolf-Rayet star is a rare and short-lived giant, burning with a fury that is millions of times brighter than our own sun. Its powerful winds travel at thousands of kilometers per second, clearing away the surrounding material and compressing it into the dense glowing walls of the helmet. This creates a brilliant iridescent landscape that is constantly changing as the star continues its frantic evolution toward a supernova. The nebula is a visualization of pure, unadulterated power, a snapshot of a star that is literally tearing its environment apart to create a monument of light. The blue and green hues of the nebula are produced by the ionization of oxygen gas, which fluoresces under the star's extreme ultraviolet light. This creates a cold, ethereal glow that contrasts with the violent nature of the star's influence, resulting in a scene of shimmering, shifting beauty. It is a structure of mythic proportions, a celestial tribute to the forces of destruction and transformation that define the most massive stars. Thor's helmet remains a striking example of how the universe's most intense fires can create the most delicate and beautiful shapes. This structure, the Homunculus Nebula, is the dramatic result of a near-fatal stellar event involving the temperamental hypergiant star Eta Carinae, which nearly destroyed itself in the 1840s. During what is now known as the Great Eruption, the star became the second brightest in the night sky, ejecting a massive amount of material that now forms twin, symmetrical lobes. These lobes are expanding in opposite directions at incredible speeds, creating a pinched hourglass shape that appears to be on the verge of a second explosion. The internal light reflects off thick dust clouds within the lobes, creating a shifting rainbow-hued glow that serves as a beautiful but dangerous warning of the star's future instability. As you consider the sheer energy required to launch such a massive amount of matter into space, feel the calm stillness of your resting body, a safe and grounded anchor against the violent history of this distant sun. The homunculus is so dense and dusty that it is opaque to visible light in many regions, hiding the star itself within a turbulent glowing cocoon of gas and debris. However, infrared observations reveal a complex network of shock waves and filaments that are still evolving nearly 2 centuries after the event. It is a living, breathing laboratory of stellar physics, showing us what happens when a star reaches the absolute limits of its own stability and survives. The name homunculus, meaning little man, was given because of the nebula's perceived resemblance to a small human figure within the lobes. Today, it remains one of the most scrutinized objects in the galaxy, a ticking time bomb that could become a supernova at any moment. Its beauty is a direct consequence of its instability, a shimmering, iridescent monument to a star that refused to go out quietly and instead left behind a legacy of fire. Within these lobes, the raw materials for future cosmic structures are being churned and prepared in the intense heat of a star's dying gasps. Picture the Pencil Nebula, an incredibly long and thin streak of glowing gas that appears as a fine, luminous line drawn with a steady hand against the blackness of the void. This delicate feature is merely a tiny dense fragment of the much larger Vela supernova remnant, representing a shock wave moving through a particularly thick patch of interstellar gas. As the shock wave plows through the medium, it creates a narrow band of excitation that shimmers with the iridescent shifting qualities of a rainbow slick on water. The nebula is so thin and sharp that it appears as a cosmic needle, a fragment of an ancient explosion that has been travelling for over 11,000 years. The linear nature of this nebula is a result of our perspective, as we are looking edge-on at a sheet of gas that has been compressed by the passing shockwave. If we were to view it from a different angle, it might appear as a broad, translucent veil rather than a sharp, luminous line. This compressed gas is heated to extreme temperatures, causing it to glow brilliantly in colours that reflect the presence of hydrogen and oxygen, reacting to the kinetic energy of the passing blast. It is a visual reminder that even the most chaotic and destructive events in the universe can leave behind marks of singular, geometric beauty in the vacuum. The Pencil Nebula is moving through the galaxy at about 600,000 kilometers per hour, a speed that would carry it from the Earth to the Moon in less than an hour. Despite this incredible velocity, it appears perfectly still to our eyes, a permanent stroke of light on the dark canvas of the constellation Vela. It represents the enduring legacy of a star's final violent act, continuing to glow and evolve as it moves through the quiet dark of the galaxy. This needle of light is a signature of the star's energy, marking the boundary of a disaster that became a work of art. The Stingray Nebula was once the youngest known planetary nebula in the entire sky, having visibly turned on and then faded significantly within the remarkably short span of just 2 decades. In the early 1990s, astronomers watched as the gas surrounding a central star suddenly began to glow as it was ionized by the star's increasing heat. This rapid transition is nearly unheard of in the agonizingly slow-moving cycles of the cosmos, where most changes take thousands or even millions of years to unfold. Allow your breath to remain slow and steady, matching the quiet, fading pulse of this distant light as it gradually surrenders its shimmering colours to the surrounding dark. The nebula is uniquely shaped like a stingray, with 2 distinct lobes and a trailing tail of gas that flows gracefully into the interstellar medium. However, recent observations have shown that the nebula is fading much faster than expected, with its brightness dropping by nearly a factor of 10 in less than 20 years. This suggests that the central star is cooling at an accelerated rate, causing the surrounding gas to lose its ionization and become invisible once again. It is a rare and precious opportunity to witness the entire life and death of a planetary nebula within a single human lifetime. The stingray serves as a poignant reminder of the transience of all things, even the massive and brilliant structures of the heavens. Its shimmering rainbow-slick light is a fleeting gift, a brief moment of visibility before the star enters its long final sleep as a white dwarf. It shows us that the universe is capable of sudden and dramatic change, even in its most distant and ancient corners, proving that the timeline of the stars can occasionally overlap with our own brief lives. We are witnesses to a cosmic disappearing act, a shimmering ghost that is slowly returning to the night. Notice how the Gomez's Hamburger Nebula perfectly mimics a common fast food sandwich through a purely accidental and whimsical alignment of dust and light in the constellation Sagittarius. This visual illusion is driven by a thick, dark dust lane that bisects a bright and puffy reflection nebula, creating the appearance of a patty sandwiched between 2 glowing buns. It is a stunning example of a protoplanetary disk seen exactly edge-on, where the dust of a future solar system blocks the light from the central star and creates a perfect silhouette. This shimmering, hypnotic pattern is a reminder that the most profound structures in the universe can occasionally resolve into shapes that are unexpectedly terrestrial and familiar. The buns of the hamburger are actually the surfaces of the dust cloud being illuminated by the hidden star, scattering light into space and creating a soft, iridescent glow. This nebula represents the absolute earlier stages of planet formation, where the raw material of a solar system is being sorted and compressed into a flat disk. Within that dark central lane, pebbles and rocks are likely colliding and sticking together, eventually forming the cores of new worlds. It is a place of quiet, dusty potential, hidden away in a shape that makes us smile and reconsider our own place in the star-forming history of the galaxy. Despite its playful name, the Gomez's hamburger is a site of intense astronomical interest, as it provides a clear view of the processes that once shaped our own home billions of years ago. By studying this cosmic sandwich, we can learn about the distribution of chemicals and the movement of gas in the environments where planets are born. It is a bridge between the cosmic and the culinary, a masterpiece of perspective and timing that reveals the secrets of a sun's birth. The shimmering glow around the edges is the first light of a new world, trying to fight its way through the obscuring smoke. The bubble nebula is exactly what its name implies, a perfectly spherical and translucent cavity blown into a dense molecular cloud by the fierce stellar wind of a massive hot star. This delicate bubble is kept inflated by the constant pressure of radiation, creating a glowing shell that looks like a soap bubble drifting through an oil-slicked pond. While the star is noticeably off-center within the sphere, its influence is absolute, maintaining the integrity of this fragile circular boundary against the crushing weight of the surrounding dark gas. The shimmering, hypnotic colors of the shell reflect the interaction between the star's heat and the cold material it is pushing against. The bubble is about 7 light-years in diameter, a space large enough to contain our entire solar system thousands of times over. The star responsible for this structure is an O-type giant, burning with such intensity that it will likely end its life in a supernova in only a few million years. As the bubble expands, it compresses the surrounding gas, potentially triggering the birth of new stars along its rim in a cycle of continuous creation. It is an environment of dynamic tension, where the push of light and the pull of gravity create a scene of perfect, temporary balance in the vastness of space. Observers often note the incredible clarity of the bubble's edge, which appears sharp and well-defined even against the cluttered background of the galactic plane. This sharpness is a result of the high-speed stellar wind colliding with the dense molecular cloud, creating a shock front that glows with ionization. It is a vision of fragile beauty, a luminous sphere held together by the very light that will eventually consume it and the surrounding cloud. The bubble nebula remains a testament to the ability of light to carve out a territory of peace within a chaotic and dense interstellar environment. Some nebulae move with a speed and ferocity that defies the perceived stillness of the heavens, such as the Guitar Nebula, which is uniquely shaped by a runaway pulsar. As this dense, spinning stellar remnant moves at over 1,000 kilometers per second, it creates a bow shock in the interstellar medium that remarkably resembles the body of a musical instrument. The interaction produces a trailing wake of gas that shimmers with an iridescent hypnotic light, marking the path of a wanderer moving too fast to ever truly be at rest. This nebula is a visualization of pure kinetic energy, a scar across the galaxy left by a star on the move. The pulsar at the head of the guitar is a tiny, incredibly dense object that was launched into space by the asymmetrical explosion of its parent star. As it plows through the thin gas of the galaxy, it compresses and heats the material in front of it, creating a glowing nose and the sweeping curves of the guitar's body. This structure is constantly changing as the pulsar encounters different densities of gas, making it one of the most dynamic objects in our astronomical catalogues. It is a reminder that the universe is not a static museum, but a place of constant high-speed movement and interaction, where the bizarre and the beautiful are in a state of perpetual flux. The Guitar Nebula represents the ultimate traveller, a lonely heart of a dead star racing through the void with no destination in sight. Its beauty is a byproduct of its incredible speed, a shimmering wake that tells the story of its violent birth and its ongoing journey across the star fields. It is a final, majestic chord in our survey of the bizarre and the beautiful, a reminder that the universe still has many songs left to sing in the dark. As the pulsar moves on, it leaves behind a glowing trail, a memory of its passing that will linger long after the star itself has moved into the distance. Lingering in the distance, these grand structures suggest a solid and vibrant presence, yet this is perhaps the greatest illusion of the deep void. Despite their breathtaking appearances in professional photographs, if you were to actually stand within a typical nebula, the gas is so incredibly diffuse that you would likely not even realize you were surrounded by anything at all. It is much like the dizzying, profound sensation of looking up into a vast clear night sky from a high mountaintop, enveloped in a thin, alpine mist that seems to vanish the moment you reach out to touch it, leaving you with only the clarity of the starlight above. From your perspective inside the cloud, the atoms are so far apart that the light they emit is spread too thin for the human eye to detect as a distinct glowing fog. You would see the same blackness and the same distant stars, unaware that you are currently floating through a monumental nursery of light. The majesty we admire from our distant vantage point on Earth is a trick of accumulated depth, a beauty born from looking through trillions of miles of thin, glowing ghosts. This realization forces a shift in our understanding of cosmic scale, where the grandest monuments are often the most ethereal. We inhabit a universe where the most visible wonders are constructed from the most invisible materials. As you breathe in the cool, thin air of this imagined height, recognize that the void is rarely as empty or as solid as it first appears. Deep within the fabric of these clouds, the universe hosts a staggering temperature paradox that defies our everyday intuition of heat and cold. The ionized gas within an emission nebula can reach temperatures of 10,000 degrees, vibrating with a searing energy that would be instantly fatal to any unprotected visitor. Yet, the microscopic dust grains drifting immediately next to this superheated plasma remain at temperatures near absolute zero, frozen in the heavy silence of the deep interstellar freeze. It is a dizzying contrast, much like the profound sensation of standing on a clear, high mountaintop, where the sun's rays burn your skin with a fierce intensity, while the wind howling past carries the biting chill of the upper atmosphere. Because the gas is so thin, there are simply not enough atoms to transfer their high-energy heat to the solid dust particles, allowing the two states of matter to exist side by side in thermal isolation. The cloud is simultaneously a furnace and a refrigerator, a place where the energetic and the frozen are locked in a silent, eternal embrace. Allow your body to rest in the stable, balanced warmth of your current surroundings, a sharp contrast to the extreme environment of the nebula. This duality is a hallmark of the low-density vacuum, where the laws of thermodynamics behave in ways that seem magical compared to the thick, uniform air of Earth. In the heart of the void, the most intense fire and the deepest ice are woven together into a single, seamless tapestry. This structure appears perfectly static and unchanging to our limited human eyes, presenting a serene and frozen image that suggests a universe at rest. However, this stillness is a magnificent lie of perspective, as the interior of every nebula is actually a chaotic environment defined by supersonic winds, massive shock waves, and the violent bombardment of radiation. If we could observe these clouds on a timescale suited to the stars, we would see them writhing and churning with a ferocity that would dwarf the most powerful hurricanes ever recorded on our home world. Standing on our high mountaintop, we might watch the stars for hours and see no movement, yet at every moment sheets of gas are being shredded and compressed by the relentless pressure of newborn suns. These shock waves travel at thousands of miles per hour, carving out immense canyons and towering pillars in the gas that seem to hold their shape only because of the vast distances involved. It is a landscape of constant, high-speed upheaval, where the very material of the galaxy is being violently reworked into new forms. The profound peace we find in the night sky is merely the result of our brief flickering lifetimes, compared to the slow, gargantuan movements of the cosmos. Behind the quiet beauty of the glowing veil lies a theatre of kinetic energy that is never truly still. We are witnessing a slow-motion explosion, a chaotic dance that has been unfolding since the dawn of time. Surprisingly, the universe builds its most massive and luminous stars entirely from the coldest, darkest, and quietest molecular clouds in existence. It is a strange and beautiful irony that the engines of the most extreme light and heat are forged within environments where all motion has nearly ceased and every photon is blocked. To create a giant that burns with the light of 1,000,000 suns, gravity requires a place of absolute stillness where the gas can settle and collapse without the interference of heat. As you look up into the vast night sky, imagine the sheer weight of these dark, silent reservoirs pressing down on the vacuum, waiting for the precise moment of their surrender. The most brilliant flares of the majestic nebulae are the direct descendants of these lightless, freezing ancestors, proving that the most intense activity must begin in a state of total repose. This transition from the silent dark to the roaring light is the fundamental heartbeat of galactic growth, a rhythmic cycle of rest and ignition. Take a moment to let your shoulders sink and your breathing deepen, finding your own pocket of quietude in imitation of these cosmic nurseries. The most powerful transformations do not always begin with a bang. They often begin in the cold, unhurried depths of a shadow. Out of the most profound emptiness comes the most blindingly brilliant fullness. If we were to look closer at the edges of these clouds, we would realize that the beautiful, sharp boundaries we admire are not physical walls or solid barriers of any kind. They are simply the fading edges of illumination, the precise point where the ultraviolet radiation from a central star finally becomes too weak to strip electrons from the gas. Beyond that invisible line, the material of the nebula continues to drift into the void, but it remains dark and invisible to our eyes, like a mountain path that disappears into the shadows. The perceived shape of a nebula is therefore a map of a star's influence rather than a map of where the gas actually ends. It is a dizzying realization that much of the universe's mass remains hidden in this way, drifting in a state of non-ionization just beyond the reach of the nearest lighthouse. We are seeing only the part of the forest that the campfire managed to light, while the rest of the woods stretch on into the infinite blackness. This boundary represents a transition of energy, a place where the aggressive fire of a sun meets the cold indifference of the interstellar medium. The sharpness of the edge is an optical effect, a beautiful illusion created by the sudden drop-off in the star's ability to command the atoms. In the reality of the vacuum, everything is interconnected, a single fluid medium that only occasionally chooses to shine. We only see the light from emission nebulae because the gas they are composed of is mostly empty space, allowing the photons to travel trillions of miles to our eyes without being absorbed. If the material in a nebula were as dense as the Earth's atmosphere, the light would be completely blocked within a few hundred yards, and these cosmic wonders would appear as impenetrable, black walls of fog. The very transparency that allows us to witness the birth of stars is a direct consequence of the staggering vacuum that defines the majority of the cloud's volume. Imagine standing on a high mountaintop looking out over a valley filled with a mist so thin that you can see every individual light in the town below, yet so vast that it colours the entire world in a soft glow. This is the paradoxical nature of the nebula. It is substantial enough to glow with the power of 1,000 suns, yet empty enough to be as clear as a polished lens. It is this balance between the presence of matter and the absence of density that creates the ethereal, ghost-like quality of the heavens. Notice the feeling of the air moving in and out of your lungs, a substance so much thicker than the gas of the stars, yet just as vital to the story of light. We are privileged to live in a universe that is mostly empty, for it is the emptiness that provides the window through which we can observe the grand architecture of the whole. The light reaches us only because the void is kind enough to stay out of its way. The very dust that annoyingly obscures our view of the galactic centre and hides the secrets of our origins is the exact same material required to form rocky planets capable of supporting biological life. While astronomers often curse these dark veils for blocking the light of distant stars, we must remember that without these microscopic grains of carbon and silicate, our own world would not exist. The nebula acts as a cosmic refinery, concentrating the heavy elements forged in ancient supernova and delivering them into the gravitational wells where worlds are born. Every mountain you have ever climbed and every grain of sand on a beach was once a part of a drifting, light-blocking cloud in the deep interstellar dark. As you envision the profound depth of the night sky from your mountain peak, recognize that you are standing on a stabilized, ancient fragment of a nebula that has finally found its way into a solid form. The dust is not a nuisance. It is the raw hardware of the solar system, the grit from which all solid reality is constructed. This connection between the obscuring shadow and the solid ground creates a deep sense of belonging within the cosmic cycle. The darkness is not just a barrier to our sight, but the substance of our very bodies and the foundation of our home. We are the dust of the nebula, gathered together into a shape that has finally learned how to look back at the stars. A nebula is simultaneously the vast graveyard of ancient dead stars and the fertile nursery for new ones, representing a continuous and unbreakable cycle of cosmic recycling. The oxygen you are breathing in this very moment was once expelled in the final violent gasp of a star that died billions of years ago, drifting through the void until it was swept up into the cloud that formed our sun. Every beautiful filament of gas we observe is a mixture of the old and the new, a tapestry woven from the threads of countless previous generations of stellar lives. Allow your resting body to sink into this thought, feeling the heavy, comforting weight of your place in this ancient and eternal process. You're part of a system that never truly loses anything, a universe that holds on to its material with a fierce and patient love. The graveyard and the nursery are the same place, and the light is always moving forward. The brilliant colours of nebulae are often completely invisible to the naked eye through a telescope, only revealed through long exposure photography, gathering photons over many hours. When we look through an eyepiece at even the most vibrant cloud, our eyes typically see only a faint ghostly grey, because our biological sensors are not sensitive enough to detect colour in such low light levels. The camera acts as a time machine of light, adding up the individual arrivals of photons until the hidden reds, blues and purples finally bleed onto the sensor. This means that the universe is far more colourful and vibrant than our own senses allow us to perceive, hiding its true glory behind a veil of low intensity. Standing on our high mountaintop under a clear sky, we are surrounded by a riot of hidden colour that we can only imagine, a secret festival of light that requires patience to witness. This realization encourages a sense of humility, reminding us that there are entire dimensions of beauty in the world that exist just beyond the reach of our immediate perception. The colours are real, but they are a reward for those who are willing to wait and look with more than just their eyes. It is a profound mystery of the cosmos that the most beautiful things are often the most modest, requiring a dedicated effort to be seen in their true light. The camera does not invent the beauty. It simply has the patience to let the beauty reveal itself. Every majestic cloud we observe is fundamentally a ghost, showing us not how it looks right now, but exactly how it appeared thousands of years ago when the light first departed. Because of the vast distances involved, we're always looking into the past, witnessing a history of expansion and collapse that may have already reached its conclusion in the present moment. The pillars of gas we admire today might have been blown apart by a supernova 10 centuries ago, but the news of their destruction is still travelling toward us through the dark. As you stand under the clear, vast canopy of the stars, Recognize that the silence you feel is the silence of the deep past. The light is a bridge between then and now, a lingering glow that connects us to a version of reality that has already vanished. We are the students of a cosmic history that is still being written in the light years between the stars. In this grand synthesis of our journey, we realize that the nebula is not merely a distant object of study, but a profound mirror of our own existence. A place where the most extreme chaos is bound by perfect physical laws, where the deepest darkness is the mother of the brightest light, and where the ashes of the dead are the only material from which the living can ever be born. In this grand synthesis of our journey, we realize that the nebula is not merely a distant object of study, but a profound mirror of our own existence. A place where the most extreme chaos is bound by perfect physical laws, where the deepest darkness is the mother of the brightest light, and where the ashes of the dead are the only material from which the living can ever be born. Deep within this moment of realization, the vast distances of the cosmos begin to fold inward, returning your focus to the stillness of your own physical form. The same gravity that pulls together the pillars of creation now draws your feet down, grounding you in the soft, heavy embrace of your bed. Your toes feel weightless now, releasing their last bit of tension, as if they were drifting into the quietest, darkest corners of a distant molecular cloud. Surprisingly, the body knows exactly how to settle into this deep, unhurried peace. The muscles of your calves and knees are surrendering their weight, becoming as still and silent as ancient dust lanes. Feel the heavy warmth spreading through your thighs, a slow-moving tide of relaxation that mirrors the patient cycles of the stars. This quiet room is the only universe that matters now. Your hips and lower back are sinking deeper into the mattress, finding the perfect support of a world that is no longer in motion. The rise and fall of your chest is the steady rhythm of a system at rest, untethered from the chaotic winds and brilliant fires of the distant void. Your shoulders are melting away from your neck, dropping into a state of total and complete surrender. The weight of the world is gone, replaced by the simple, comforting pressure of the blanket against your skin. Every muscle in your arms has found its place in this stillness. The back of your head is cradled by the pillow, a soft and unchanging anchor for your thoughts. In the dim light, your jaw is loosening, and the small muscles around your eyes are finally letting go. The forehead is smooth, and the scalp is relaxed, as if the very air in the room is a soothing balm. The breath moves through you now without any conscious effort at all. It is a slow, rhythmic presence, a gentle tide that arrives and departs in a perfect, quiet loop. You're safe here, surrounded by the familiar scent of the linens and the deep, heavy silence of the night. The room is a sanctuary of peace, a small and perfect world where the only light is the softest glow of memory. Everything is quiet, everything is still, and everything is exactly as it should be. The journey has come to its natural end, and the rest you have earned is finally here. And now, 101 wonders are resting with you. Sleep now. Good night.